Hi everyone, in this video I will be going through IGCSE Chemistry 0620 questions where students often lose marks. Not because they don't know the content, but because they misread or misinterpret the questions. So with the exam just around the corner, I will be covering these common mistakes chapter by chapter so you can better understand what examiners are really asking and avoid the usual traps. Let's get started. Let's take a look at some question from chapter 1, that is states of matter. We will go through a few examples and talk about how to tackle them correctly. Okay, first question. A student places a gas jar containing ammonia above another jar containing hydrogen chloride. After some time, a white ring forms closer to the HCl jar. Which of the following best explain this observation? If you check this question, you can see that there are two gases that are diffusing with each other, and this question is related to diffusion. And from chapter 1, you will always get one question that will be related to this topic, diffusion. So for that, you must have to remember one thing, that is the diffusion rate is inversely proportional to the mass of that compound or mass of that gas. Okay, it's inversely proportional. So many students do the mistake by thinking that it is directly proportional. Higher the mass, higher will be diffusion rate. So this is wrong. Okay, if higher the mass, then the diffusion rate will be slower because they are inversely proportional to each other. And if you see here, the white ring means it is the ring of ammonium chloride, because whenever ammonia and HCl will react, you will get ammonium chloride. So it means the ring is formed near the HCl jar. What does it explain? It explains you that HCl moves a little. If you see a jar and you have HCl here and ammonia here, and you are getting a ring near the HCl, it means HCl travels little, whereas ammonia travels more. So what did we get from here? It means that ammonia is lighter in weight. That's why it diffuses faster. Okay, so we have to choose an option in which they are talking about ammonia that has a lighter weight. So the option C, if you see, ammonia has a lower relative molecular mass than HCl and diffuse faster. So this is the right option. So what you have to remember? You have to remember that the mass is inversely proportional to the diffusion rate. So option C is correct. Let's see another question related to diffusion. Sometime you will get the options from the periodic table. And so many students get confused. They think that, okay, relative mass is the actual one that is deciding. But they forget that diffusion only occurs in gases and liquids. Okay, so if you see over here, which of the following gas will diffuse fastest in the air? Sometimes students think that sodium, magnesium, and they start looking at the periodic table. Remember that if you see any metal in the question related to diffusion, you have to just ignore them because they are solid at room temperature. So you cannot choose any solid for diffusion. So what you are left behind with, you are only left with two options, that is fluorine and neon. One belongs to group 7 and the other one belongs to group 8. Okay, so if you see the mass in the periodic table, the fluorine has a 19 mass, whereas neon has 20. So many students usually choose fluorine in this option. That is wrong. Why wrong? Because you have to remember that these elements in the nature or in the at room temperature, how they are present. In nature, fluorine is present in the form of diatomic molecule. So it means its mass is not 19. Its mass is actually 38. Okay. So the mass of fluorine is 38, whereas neon is 20. Why only 20? Why it's not monoatomic? Because it's a noble gas, and noble gas do not form any molecule. Their electronic configuration is complete. Okay, so which gas will diffuse fastest in the air? Of course, it will be neon. Okay, so I already told you, if you see the options of the metals, or if you see the option of any solid that you already know in the periodic table that it is solid, okay, especially the metals, then you have to ignore those options. And the remaining option, if you see a element from group 7, then you have to consider it as a diatomic molecule. All group 7 elements are diatomic molecule. Okay, and all group 8 elements are are monoatomic. So that's why option D is the right option. Let's see another example. Which of the following gases will diffuse the slowest? Okay, so now you have to check the one which has the highest mass. Okay, highest mass means it will diffuse slower. So potassium and calcium, again you have to reject these options because they both are metals. They will be solid at room temperature, so you have to just ignore them. Now we are just left with chlorine and xenon. So if you see, chlorine is a diatomic molecule and 35.5 is the mass written in the periodic table. So it will be how much? 71. But if you look at for the xenon, xenon mass is 131 gram in the periodic table. So who has the highest mass? It is xenon. So option D is the right option. So highest mass, it means it will diffuse the slowest one. So that's why these are the questions that usually students get confused. They usually sometimes choose the Nobel, they compare the Nobel, they forget about the group 7 elements. They think that they are monoatomic, but actually they are diatomic. And another mistake they usually do in the metals, okay? They think that, okay, metal has a smaller mass, so okay, metal can be the option, but it is wrong because they are solid, so you don't have to choose any solid for the diffusion question, okay? I hope this point is clear to you. Okay, now let's see some questions related to chapter 2, atomic structure, okay? We will see some of the example related to chapter 2, atomic structure, and see how we can avoid some common mistakes in these questions. Let's see this question. Rubidium has two isotopes. Which statement explain why both isotopes have the same chemical properties? The common mistake done by the students is that they think that isotopes have the same proton number. So the option of proton number is the right option. Okay, or they have different neutron numbers, so that is the right option. But you have to read the question carefully. They are not asking about that what does isotope means. They are asking what is the reason behind that they have same chemical properties, because isotopes have same chemical properties but different physical properties. Okay, so the reason behind same chemical property is not the proton number. They have same proton number, but it is not the reason. The actual reason is electrons, because all the chemical properties depend on the electron number, the large shell electrons, because actually these electrons are involved in all the bonding in all the chemical reaction. The proton number never change, only the electrons are lost or gained, and then these metals or non-metals become ions, right? So it means only electrons are actually involved in deciding the chemical properties of any element or compound. So that's why you have to always, if they are asking in question that which, like why they have same chemical properties, if they ask you about anything, any compound, any element, the reason is they have same electronic configuration or they have same large shell electrons. Okay, that should be your choice. Don't choose the proton number, because proton number is not deciding the chemical properties. So I hope this point is clear to you. So B option is the right option. Let's see another question. Which of the following is the correct electronic configuration for calcium ion? Mostly the student do the mistake in this type of question. They forget the word or they misinterpret the word ion, or sometimes they ignore this word. So they just think that, okay, let's see the what is the atomic number of calcium. So atomic number of calcium is 20. So they just think that the first shell has 2 electrons, the second has 8, third also have 8, and then the fourth has 2. So they usually choose this option in the exam, that is A, which is wrong. You have to choose the option of the ion. It's already mentioned here that we have calcium ion. And even if the ion is not mentioned here, 2 plus, you have to look at the periodic table. Calcium belongs to group 2. It means it will lose 2 electrons. So the last 2 electron will be lost. So what will be the remaining electronic configuration? That is 288. So that's the B option is the right option. Please be very careful when you are looking for the ions or the atom. That what the question is demanding the electronic configuration of ion or either the atom. So you have to read the question carefully. In this question, they are asking about ion, not about the calcium atom. So that's why option B is the right option. Question number 8. What is the nucleon number of an atom? Another common mistake the students do is that they misinterpret the word nucleon. They think that it is the mass of a nucleus because the names are same. That is wrong. And sometimes they think it is the number of the neutrons because the name is same. That is also wrong. Nucleon means that the nucleon number means anything that is present inside the nucleus. And we know that in atom, Which particles are present in the nucleus? That are neutrons and protons. So actually the nucleon number is the number of neutrons and proton together. It's not the number of neutrons only, or it's not the mass of a nucleus. So most of the students get confused with this option and also with this option. So that is wrong. Okay, you have to choose the option C, the number of the protons and neutrons in the nucleus. That is the right option. That is option C. Okay, so these were the questions that were related to chapter 2. Now I will give you some example from chapter 3 and the common mistake they usually students do and how you can avoid them. And the chapter 3 is related to chemical bonding. Okay, let's see this question. Which type of bonding is present in magnesium chloride? Most of the students get confused about the bonding that is present in different compounds. Either it's covalent bond, it's ionic bond, or metallic bond. So to solve this trick, you have to first look at the elements that are present in that compound. If you see, we have only two types of the elements present. One is magnesium and the other one is chlorine. And the periodic table will be given to you in the exam at the end of the paper. So you can see at there that in the periodic table, magnesium belongs to group 2. So it means it is a metal, whereas chlorine belongs to group 7 and it is a non-metal. Whenever you have one metal or one non-metal or maybe two non-metals in this case, so it means the combination of metal and non-metal will always produce an ionic compound. There is no doubt in it. Only ionic compounds can be made through the metals and non-metal reaction. So you have to choose the best option that can decide. So if you see here, the option B has ionic bond. It is written already here. So the bonding that is present is ionic bond, and no other option is showing the word ionic bond. So it means you don't have to read it completely. Just choose the option B. That is the right option. Okay. So option B is correct. Let's see another question. The table shows the electronic structure of 4 atoms. If you can see over here, the electronic structure is already given. Which 2 atoms combine to form a covalent compound? So again, this question is asking about the bonding in the covalent compound. So remember that covalent compounds are always made by non-metal and non-metal. Okay, even if the students know that they are made by non-metal and non-metal, then how they will decide that which one is a non-metal? Remember, you have to remember the group number. Group 1 to 3 are always metals, whereas group 4 to 7 are the non-metals. And group number always tells you the last shell electrons. So the last shell electrons, we can see here how many electrons are present in the last shell? Only one. It means W belongs to group 1. So it is a metal. It's not a non-metal. So it is not involved in covalent bond. X belongs to group 4. It means it is also, it's a non-metal, right? Because 4 to 7 are the non-metals. It means this is involved in the covalent bonding. Let's see about Y. Y belongs to group 7. If you see the last shell electrons, it's 7. So it means the group number is 7. So it is also a non-metal. If you see this one, Z belongs to group 8. It means it belongs to group 8. It is a noble gas, and noble gases don't react with any other element. Their electronic configuration is complete. They don't need any electrons. So it means noble gas will not react with anyone. So we are just left with X and Y. So when X and Y will react with each other, they will give you a covalent compound. So this is how you can solve the question. So you have to remember that group numbers are actually the one that are deciding the number of electrons in the last shell, and period number decide the number of the shells. For example, it has 3 shells, so it means W belongs to period number 3. These all of them belongs to actually period 3 because they all have 3 shells. Okay, so now which option is right? Option C is the right option because X and Y both are non-metals. Let's see this question. Question 12. Ammonia is a covalent molecule. Which diagram shows the outer shell electron arrangement in a molecule of ammonia? This question is a must question in an exam. You will see this question, but most of the students who do the mistakes is that they know the how the ammonia will form the bonding. They know this one, but they forget about the electron pairs that are not involved in bonding. For example, most of the student will try to choose an option A, which is wrong. Why? They think that, okay, ammonia is making 3 bonds with H, right? So they think, okay, 1 bond, 2 bond, and 3 bond. And they think that, okay, option A is right, which is not right. Why? Because if you remember, if you see in the periodic table, nitrogen belongs to group 5. So it means it should have 5 electrons in the last shell. But if you see here, they are just showing 3 electrons. Where are the remaining 2 electrons? You have to show them in your electronic configuration, because whenever you are drawing the structure, you are drawing the structure of the last shell electrons, all the electron present in the last shell. So option C is the only right option, because you can see these 2 electrons also here, but you cannot find these electrons here and also not here. So that's why option C is the only right option. Please don't forget about the lone pair, or the pair of the electrons that are not involved in the bonding, but they are present in the last shell. Okay, you have to remember them. Just look at your periodic table if you are confused, and you can know that how many electrons are present in the last shell. Okay, so option C is the right option. Question 13. Which diagram shows the covalent bonding in a molecule of carbon dioxide? Again, how you will know that it's a covalent bonding? It's already given in the question. But sometimes if they don't give you in the question, you just have to look for carbon. Carbon is a non-metal, and oxygen is also a non-metal. So it means it's a covalent compound. Okay, whenever you are looking at the bonding, you have to remember their last shell electrons. How many electrons are present there and how many they need them. So if it means if carbon belongs to group 4, how many electrons it needs? It needs 4 electrons. So its oxidation number is 4. Whereas oxygen belongs to group 6. So it has 6 electrons in the last shell. So how many electrons it needs? It only needs 2 electrons to become 8. So that's why the oxidation state of oxygen is 2, whereas the oxidation state of carbon is 4. So oxidation state is the state which will decide that how many electrons an atom can lose or gain or can share. So carbon should share 4 electrons now, because its oxidation number is 4. You can easily see here, right? Whereas oxidation number is 2, because it belongs to group 6, so its oxidation number is 2. It just needs 2 electrons to complete its outermost shell. So oxygen must make 2 bonds. So if you see, this oxygen is also making 2 bonds, and this one is also making 2 bonds. So that's why option C is the right option. Okay, I hope this point is clear to you. So oxidation state will be the one that will decide the bonding. How many number of bonds an element can form or an atom can form, it depends on its oxidation number. Let's see another important question that is related to intermolecular force, or the attractive force you can say, between molecules. One thing you must know, that intermolecular force is only present in the covalent compounds. It is not present in the ionic compound. It is not present in the metallic elements. Okay, only covalent compounds have intermolecular forces, and these intermolecular forces are actually the weak forces, and these forces are usually present between the molecules. Okay, between molecules. For example, if you have a water molecule, right? This is H2O. So which bond is present? Hydrogen is a non-metal. Oxygen is also a non-metal. So this is a covalent bond present in it. If I write the structure of the H2O, you can see. So what is this bond? This is covalent bond. Okay. So in one bottle of water, you don't have only one molecule of water, right? You have so many molecules of water. So these molecules are connected with each other through weak intermolecular forces. We can also call them intermolecular forces, okay? So that's why the boiling point of water is low. Why? Because when you boil it, this force will break. So in exam, if they ask you that why, which statement describe the attractive forces between the intermolecular forces or whatever, you have to choose the word weak forces. Okay, intermolecular forces are always weak, so option C or D can be right, because they are weak forces. And where are they present? They are only present in the covalent compounds. No other element or no other ionic compound they are present. So which option is right? They are weak forces formed between covalently bonded molecules. So it means option C is the right option. They are weak forces that hold ions together. No, that's wrong. Okay, they are not present in the ionic compound. So option C is the right option. Again, a similar question that is related to the intermolecular forces. Student does a lot of mistake in this one, Because if you see, why do most covalent compounds have low melting point? They think that, okay, covalent bond is a weak bond. That's why they have the low melting point. So what they usually do, they choose the option A because their atoms are loosely held together by weak covalent bond. Again, this is wrong. Covalent bonds are very strong. They are not weak, okay? So what is the thing that is responsible for the low melting end point? It is actually the weak intermolecular forces, or we can also call them weak attractive forces between molecules. So that's why you have to choose that option, because their molecules are held together by weak intermolecular forces. Yes, this option is the right option. Whenever they ask you about the melting or the boiling point of the covalent compounds, the reason behind is not a covalent bond. The reason is always the weak intermolecular forces, or you can say the weak attractive forces between molecules. Okay, you always have to choose that option. So that's why option B is the right option. So this option has the right option, that is B. Let's see another question. This is also related intermolecular forces. I'm just giving you 2 or 3 examples so the concept is clear to you. Which statement explain why methane has lower boiling point than water? If you see, methane is CH4. It's also a covalent compound. Water is also a covalent compound because it's made up of non-metal. This one is also made up of non-metals. So it means both are covalent compounds. So why one covalent compound has a lower melting point than other covalent compound? Again, it is the reason behind is the weak intermolecular forces. So you have to look this one. Methane has weaker covalent bond. Again, wrong. Covalent bonds is not responsible for lower melting or boiling point. Methane has weaker attractive forces. Yes, this option is right. Methane has weaker attractive forces than water. Okay. Water also have weak attractive forces, but methane attractive forces are more weaker than water. That's why the methane boiling point is lower than the water. So that's why this option is the right option. And remember that methane molecules are heavier than water molecules. Melting and boiling point don't depend on any other factor. They just depend on the bonding. Which bond is present will decide the melting and boiling point of any compound. Okay. So the bonding for covalent compounds, which bond is actually responsible for lower melting or boiling point? It's not the covalent bond. It's actually the weak intermolecular forces, or you can say intermolecular force or weak attractive force. Okay. So that's why option B is the right option. Let's see another question. Question 17. Which of the following best explains why graphite, metal, and molten ionic compounds conduct electricity? Okay, to conduct electricity, you need 2 types of charged particles. Either they should be ions or electrons. Okay, only free moving electrons or free moving ions are responsible for conducting electricity or electric current, you can say. So we have to check in which compound either we have ions or electrons. So if you look at the graphite, graphite has free moving electrons. So it has electrons, that's why it can conduct electricity. And it is the only covalent compound that can conduct electricity. All other covalent compounds or elements, they cannot conduct electricity. Graphite is the only covalent, element, okay, not a compound. It's the only element that can conduct electricity. Metals. Metal can also conduct electricity because they have free moving electrons. Free moving electrons are responsible to conduct electricity in metals. That's why metals and graphite, both in the solid form, they can conduct electricity. Ionic compounds, they have ions in them. There is no free electrons, they just have ions. So ions are responsible for the electrical conductivity in ionic compounds. That's why ionic compounds are very bad conductor of electricity when they are in solid form. Why? Because in solid form the ions are not free. It's not only the ions, the free moving ions are actually responsible for to conduct electricity. Okay, so in ionic compounds we don't have free ions when they are solid. Only in the molten form or in the aqueous form they have the free ions. That's why ionic compounds are good conductor of electricity when they are in the aqueous solution or when they are melted. Okay, so what is responsible for the electrical conductivity in ionic compounds? Same, from the words ions. Okay, so now we have to look at the option that can describe electrons and ions together. All have loosely held protons. Wrong. Protons are positive charged particles. They are not responsible for the electrical conductivity. All have free moving electrons that can transfer energy. Okay, electron is right, but not all of them have free moving, because only metals and graphite have free moving electrons, but not the ionic compound. So we cannot choose this option. Let's see another option. All have mobile. Mobile means free moving charged particles. Yes, that option is right, because electrons are also particles, ions are also particles. So we can use the word particles for both electrons and ions. So all have mobile charged particles that can carry the current. So that's why option C is the right option. You have to remember, free moving electrons are responsible to conduct electricity only in metals and graphite, but not in ionic compounds. In ionic compounds, free ions are actually responsible to conduct electricity. So that's why option C is the right option. Let's see question 18. The diagram represents the general structure of solid Z. If you see, we have positive ions and small electrons. Okay, sometimes the students get confused with the metallic structure and ionic lattice structure, because in ionic compounds, we have positive ions and negative ions, right? And same in the metal. In metals, you will see the positive ions and electrons. So if you look at the option, it is a metallic compound, metallic element, sorry. So metal, can you find any metal here? It's the only one metal that is present, it is aluminium. So option A is the right option. But sometime in exam, if they give you sodium chloride, so you can be confused. You can think that, okay, it can be sodium chloride because it has positive and negative. So the trick is that the positive and negative ions size will be not so, the difference between the size will be not so large as you can see in this picture. Electrons are very small charged particles. So usually in the exam, if they give you a metallic structure, the negative charge will be too small compared to the positive ions. You can see here. But in the metallic lattice, but in the ionic compounds, if you see the structure, the positive ions and negative ions might be same in size, or positive can be bigger and negative can be smaller, or negative can be bigger and the positive can be smaller. Okay, but the difference will not be as much as you can see here. Okay, electron size is too small compared to the metal ion, so it is usually a metallic element, it's not an ionic compound. I hope this point is clear to you. So if you are looking at positive and negative, you should see that electron will be very small compared to the negative ions in the ionic compound. So that's why option A is the right option over here. Okay, so these were all the questions related to chapter 3. Now I will give you some example related to chapter 4 and the common mistakes the student do in chapter 4, chemical formula and equation. Let's see this question. The ionic half equation for the formation of oxygen during the electrolysis of aluminum oxide is shown. What are the values of X and Y? Most of the students are very good in balancing the equation. They know that two oxygen are present here. So here we have only one. So it should be 2. Okay, but the common mistake the student usually do is, so these two options can be right. So the common mistake the students usually do, they forget to multiply this the oxidation number with the coefficient. So 2 into 2 is 4. So your answer should be 4 electrons. It should not be 2. They think that, okay, we have 2 oxygen, so it means it should be 2 electrons. No. If you see, one oxygen has 2 oxidation state. It means it is gaining 2 electrons here, right? So if it will lose 2 electrons. One oxygen will lose 2 electrons, but here we have 2 oxygens, so it will lose 4 electrons. So whenever you are balancing the equation, don't forget to see the oxidation state and multiply with the coefficient so you can get the exact number of the electron. So option D is the right option here. Let's see this question. This question is very important. Sometimes when the students are making the formula, for them it is very easy. They just cross multiply. For example, sodium oxidation is plus, and then if you see the oxidation state of hydroxide ion, it is -1. So they just cross multiply these their oxidation state, and they can easily guess the formula, right? NaOH. Or I can give you another example. For example, we have calcium chloride, CaCl2. How they can get this formula? Calcium has a +2 oxidation state, chlorine has -1, right? They will cross these oxidation state, and then Ca will be 1 and Cl will be 2, right? So that is how they can make their formula, the molecular formula they can easily make for the covalent compounds. But there, when there are more than two elements present in a compound, how you can make the molecular formula? Like in this question, they have given you three elements now, and how you will make the molecular formula, that is the most trickiest question. So for that purpose, you don't have to write like this. Cannot cross multiply the two elements, because now we have three elements. So for that purpose, you have to remember that overall charge on a compound is always zero. So you have to try the oxidation state that the overall answer becomes zero. Okay, so let's see now one by one. We have three element present, and each of them has different oxidation state. Okay, we have two different ions and one oxygen. If you see, one of them is negative, has a negative oxidation state, and the other two has the positive one. So it means the positive number should be equal to negative, so your answer becomes zero. So if you see, Fe is 2 plus, Fe is 3, this one is 3 plus, and then we have O2 negative. So how many positive charge we have? We have 5 as a positive charge, right? And how many oxygen we have here now? Only we have -2 charge. So we have to balance this plus 8 or -2. We cannot make it plus 2, right? So we have to make it -5, but it is not possible because this is an odd number. We cannot change it. So what will be the right option to do? If you see over here, they are two different um, ions. Okay, they are not the same ions. You cannot say they are same iron because they both are iron. No, they are two different. So now you have to treat them differently. How you will treat them? You can see which one is an odd number. Try to make that even. Okay, so which one is the odd number? This one, Fe3 plus, is an odd number. So try to make it even. So what I can do, I can make it 2Fe. So when I will make it 2Fe, now the charge will be +6, right? 2Fe will have a charge of, you can just write +3, but it will become +6, okay? So it has a +6 charge. What about this one? It is still 1, so its charge is +2. So now we have 8. Can I make this one 8? Yes, now it is easy. I can make it 8. -2, how many oxygen I need to make it 8? Just 4 oxygen, right? So then it will become -8. So it means I need 4 oxygen. And how many iron I need? I need 2 these iron and 1 this iron. So total 3 iron I need. So now the formula is Fe3O4. Okay, so that is the right option. You can choose how you will decide. You can decide by making the compound overall charge 0. So it will be helpful for you to make the formula. So option D is the correct option. Let's see another example. This is also another example, and we have how many ions in this one? We can see sodium ions. This is the same like the previous question. Okay, sodium ions we have oxygen ions, and we have chromium ions. Again, we have 3 ions over here. So you cannot decide that what will be the through the cross multiplication. Okay, you cannot decide the formula through cross multiplication. So this is how you will do. They already have given you the formula, and they are asking you now what is the oxidation state of chromium in this salt. So if you see, we have Na2, Cr2, and O is 7. So how many, what is the oxidation state of oxygen? Of course, it's -2. So -2 into 7 is equal to 14, right? Your answer should be 0 at the end. If this one is -14, then it means this should be +14 because both of them are metals, and metals always have a positive charge, right? So sodium, how many sodium we have? 2, and one sodium has an oxidation state of +1. Why? Because it belongs to group 1. So group 1 means it has the oxidation state of +1. So now we have 2 sodium. So this is +2, right? So how many left? We are left with +2, and this is -14. So it means chromium is how much? Chromium is +12, right? So now the oxidation state of chromium is +12. But if you look at here, the chromium are 2. So it means now total is 12, but each one of this is 6. So the chromium oxidation state is 6, right? And when you have 2 chromium, it will become 12. So 14, positive 14 and -14 will cancel each other, and you will get overall charge 0. So that's why the oxidation state of chromium in this salt is plus 6. Don't get confused. Don't choose the answer plus 12, because you can see over here clearly in the formula that we have 2 chromium. So each chromium has an oxidation state of plus 6. Okay. Same is like for oxygen. You cannot say the oxidation state of oxygen is minus 14. It is actually minus 2, right? But we have 7 oxygen, so that's why the total is minus 14. So option C is the right option. So this is, I think now this is clear to you how you can make the molecular formula, or how you can interpret the oxidation state if the formulas are bigger. They don't have 2 elements, they have more than 2 elements. Then how you can calculate? You can easily calculate by finding the total mass, total oxidation state should be 0, okay, for a compound. Then you will easily find the oxidation state of the elements present in that compound. Let's see another question. A compound contains 24 gram of carbon and 4 gram of hydrogen. What is the empirical formula of the compound? Okay, so most of the students, what they do a mistake. They just cross multiply this one. They think 4 gram is hydrogen. So if 4 6 are 24, so what will be happen? The carbon will be 6 and hydrogen will be 1. So they usually choose this formula, which is wrong. Empirical formula will always be decided by the mole number, okay? The mole number actually decided the formula. So you have to calculate the moles of these carbon and hydrogen. Let's find the moles, and the formula for the mole is mass given divided by molar mass. This is the first formula for the moles. We have 3 different types of the moles formula, but this is the common formula that is used because we have given the mass is given in the grams, right? So this one will be the mass. We can just use 4 gram of hydrogen. And what is the molar mass? You can just look at your periodic table. It is 1 gram. So the moles of hydrogen is how much? Now 4. So hydrogen is 4. This is what you will get. What about carbon? Carbon is 24. And if you see the mass of the carbon in the periodic table, it is 12. So it is 2. So it means you have 2 carbons, right? This is the molecular formula of the compound. So what the students do usually, even if they know the mole ratio, how to calculate the mole, they will choose the option C. They think that C2H4 is the right answer, but it's wrong. They are not asking about the molecular formula. They are asking about empirical formula. So what does it mean? Empirical formula is the shortest, simplest ratio of the elements present in a compound. So you have to make it more simple. That is CH2, right? So CH2 is the right answer for this question. So B is the right option. Okay, so these were all the questions related to chapter 4. Now let's see some example related to chapter 5, chemical calculations, and we can see what are the common tricks you have to remember related to this chapter. Question 25. Okay, in chapter 5, there are 2 main things that you have to remember. First, you have to remember the formula of the moles, and the second thing, you have to remember the Avogadro's constant value, and you should know that what does Avogadro's constant mean, okay? So the first thing I will explain you that 1 mole of any compound, if we are talking about compound or molecules, 1 mole of molecules in any compound contain 6.02 into 10 raised to power 23 number of the particles, you can say, or 1 mole of the atoms also have the same number, okay? It can be molecule or it can be atom, okay? So anything, or maybe if we are talking about ions, if it is 1 mole, again the ion number will be 6.02 into 10 raised to power 23. Only the size can differ, but the particles number will remain the same. So this equation you have to remember, okay? This value you have to remember. So now you can find the answers in the exam. For example, they say which gas sample contains the most molecules. So the student just will be start thinking, okay, 36 is the biggest number. Let me choose this one. Or sometimes they will choose the gram. Okay, 14 gram is the bigger one. Let me choose this option. That's wrong. You have to find the mole. Again, the questions are related to the mole from chapter 5. So the one which is more than 1 mole or it is 1 mole, it means it has 6.02. So the more the number of moles, more it will have the number of the particles. So they are asking about the most molecules. So if you see carbon dioxide, Remember that any gas at a standard room temperature and pressure has a volume of 24 dm cube if it is 1 mole. So they already told you that carbon dioxide is 24 dm cube. What does it mean? It means carbon dioxide is 1 mole. Okay, let's see for hydrogen. Hydrogen H2, if you see the mass of hydrogen, it is how much now? 2. Hydrogen is 1. Okay, and then if you have 2 hydrogen, then the mass will be 2, right? And 4 gram means mole is equal to mass given over the molar mass. So 2 and this is 4. So it means you have 2 moles of hydrogen gas. Let's see for 36 dm cube of hydrogen chloride. So hydrogen chloride gas 36 means 24, right? 24 is for the 1 mole, and the mole formula is equal to volume divided by 24. So it is 1.5. This is another formula for the mole of the gas. If you want to calculate the moles for a gas, this is another formula. I will give you now these formulas in the next question. So it means this is 1.5 mole. And let's see for the nitrogen. Nitrogen has a mass of 14 gram, but N2 means it should have a mass of 28 gram. So 28 14 divided by 28, the given mass divided by the molar mass, what you will get? You will just get 0.5. So this one is 0.5 moles. Which one is the biggest number? 2 moles. So it means hydrogen option is the right option because it has 2 moles. So it means it will have double the number of this one. 6.02. This one has 6.02. This one have more than 6.02, but this is now double of the 6.02. Okay, so 1.24 almost. So that's why B option is the right option. More the number of moles, then the more the number of the molecule will be present in that compound or in that element. Okay, so option B is the right option. Let's see another example related to this question. Which sample does not contain a number of atoms equal to Avogadro's constant? First of all, you must know what is the value of Avogadro's constant. That is 6.02 into 10 raised to power 23. Okay, now what is the common mistake the student will do? They will just look at 14 gram of nitrogen. Okay, they think that, okay, nitrogen is 14 grams, so it means it's 1 mole. Water mass is 18 grams, so it is not 1 mole. This one is less. Helium. Helium is 4 grams. The mass is 4 grams, so it means it's 1 mole. Carbon monoxide, the mass is 28 gram. If you calculate, this is 16 and this is 12, so it is also 1 mole. So it means B is the right option. That's wrong. Okay, you don't have to calculate like this. You have to first check the question carefully. They are not asking, they all of them are molecules, right? Except this one. Okay, they are molecules, and they are asking about the number of the atoms, not about the molecules. So this is the question, or this is the option the student will, these words the student will usually neglect, and they will choose the wrong option. Okay, so first what you have to do, you have to find the number of the moles of the molecules, because they all are molecules, right? So let's see the moles of molecules. N2, N2 actually the mass is 14 into 2. Why? Because nitrogen has a mass of 14, so the molecule mass is now 28 gram. Let's see now the formula for mole. Mole is equal to mass given our molar mass. So what is the mass given? It is 14 gram, and molar mass is 28. So what is the answer now? 0.5. 0.5 moles of N2 we have now here. Okay, this is the molecule, but we have to find the atoms. How we can find atoms? We can just look in this question and we can see N2. N2 has how many atoms? 2 atoms. Nitrogen, 2 nitrogen atoms. So we can just multiply with this one and you will see you will have 1 mole of atoms now. Right now it is converted into atoms. We have 0.5 mole of molecules of nitrogen, but we have atoms are 1 mole. So 1 mole is same like Avogadro's constant. So this option has been rejected. Now let's see for water. Water, if you see, water mass is 6 gram, and then the molar mass is actually 18 grams. So the answer is 0.33. Okay, so water has 0.33 moles of molecules. not atom. Okay, now let's see how many atoms it have. 1, 2, 3. So just multiply this number with 3 and you will get again 1 mole. So what does it mean? It means water also, 6 gram of water has 1 mole of atoms. 6 gram of water has 1 mole of atoms, and 1 mole of atoms always have 6.02 into 10 raised to power 23. That is Avogadro's constant. So this option is also now rejected. Let's see option C. 4 gram of helium. If you see the molar mass of helium, it is 4 gram. Okay, and it is already given, the mass given is also 4 grams, so this is also 1 mole. It means that helium is also equal to Avogadro's constant. So now we are just left with option D, and that is the right option. Why? Let's see. Because the mass of carbon monoxide is 28 and the given mass is also 28. So carbon monoxide moles are how much? 28 over 28 is 1 mole. 1 of mole of molecules it contains. But we are looking for the atoms. How many atoms are present? 2 atoms. So 2 into 1 is equal to 2 moles of atoms are present. It means in carbon monoxide, it is not equal to Avogadro's constant because the value is bigger than 1 mole of atoms. 1 mole of atoms has Avogadro's constant, but it is double the Avogadro's constant, right? So that's why option D is the right option. I hope this point is clear to you. Whenever you are looking at Avogadro's constant, first of all, you have to find the number of moles. And second, then you have to read the question carefully. Either they are asking about atoms or they are asking about molecule. Okay, in the previous question they were asking about molecules, that's why I did not change it to atoms, but here they are asking about atoms. Okay, so you have to change the molecules into atoms if they ask you about the atoms. Okay, so that's why option D is the right option. So these are some of the common mistakes the students usually do related to Avogadro's constant or the number of the particles present in a compound or in an element, if the question is related to like these type of questions. So now let's see about other questions that are from chapter 5, and the student usually get confused at which formula they have to use. Remember that there are only 3 formulas that are the most common formulas from chapter 5, and your all answer will be just related to those formulas. You will have to use just those 3 formulas and you can easily get your answer. The first formula is mole is equal to given mass over molar mass. Okay, what you need, you just need given mass or maybe moles. Okay, because molar mass you can easily calculate from periodic table. You don't need this one, so you just need one of this information and you can easily calculate the other information. And usually this one we use for solid information. In, for example, in the question, if they give you any information related in grams, then you have to use this formula. Okay, now let's see a second formula. That is also the formula of mole. Mole is equal to concentration into volume. This formula is usually used for the solutions, if you have solutions or liquids. Okay, the third formula is for the gases. Mole is equal to volume over 24 dm cube. Okay, and your volume and concentration should also be in dm cube. If the question is not giving you the information in dm cube, you have to convert it. Okay, mostly they give in centimeter cube and then you have to convert it by dividing with 1000, so your answer will be in dm cube. So these are the 3 main formulas that you will be using in all the questions. So you have to remember these formulas, and when you went for the exam, just write these formulas with the pencil on your paper, and at the end you can remove it. Okay, because only these 3 formulas will be repeated in all the questions related to chapter 5. Now let's see this question. Which sample of magnesium chloride MgCl2 contain the same number of moles as of 69.6 gram of potassium sulfate K2SO4? So it means the information is given in the form of grams and you have to find the number of moles. So which formula we are going to use? Of course, the first formula, because the information is given in grams and we have to find the moles. So what will be the moles of the which moles we have to find? Which sample of magnesium chloride contain the same number of moles? So it means we have to find the moles of MgCl2, right? And the given mass is, we don't know the given mass also, right? And then we have to find also the molar mass, right? So molar mass we can easily calculate from the periodic table, but we don't know these two options, right? So first you can find the molar mass of the MgCl2, and that is 95 gram, right? So this is 95 gram per mole. So we have to find what? We have to find the mass. Mass we have to find. So what we should have? We should have the mole. Let's now calculate the mole. How we can calculate the mole? Let's see the other information which we already have. We already have the mass of potassium sulfate. Okay, potassium sulfate mass is already given, so we will use this formula again. So mole of K2SO4 is equal to given mass, which is 69.6 gram, and divided by the molar mass of potassium sulfate. And what is the molar mass? You can calculate from the periodic table. It will be 174. So what will be the answer? 0.4 mole. And they use the word same, contain the same number of moles. It means the number of moles of K2SO4 and MgCl2 will be equal. So you can also put this value over here now because they both are equal, right? So 0.4 is equal to how much the mass? Just multiply this one here now, 0.4 into 95, you will get the given mass, okay? So given mass will be how much now? 38 gram. So this is how you just calculate. You are just using one of the formulas of the moles and you have easily get your answer. So this is the option. Which option is right now? Option C is the correct option. Let's see another question that is will also use the same formula of the moles, okay? But you have to read the question again carefully. What is the concentration? So now the question is related to concentration. You have to find the formula. You have to now decide which formula we can use. So I already gave you the formula, the second formula, that is mole is equal to concentration into volume. It means we are going to use this formula because we have to find the concentration, right? So what is the concentration of a solution that contains 25 gram of NaOH in 500 centimeter cube of water? So centimeter cube means it's the volume. So we are already given. First we have to change it into dm cube. 500 over 1000. How much we will get? 0.5 dm cube, right? So now we have to find the concentration, but we don't know the number of moles, right? How we can find now the number of moles? Do we have any other information? Yes, we have the information of NaOH, that is 25 gram. It means which formula now we have to use for the mole? The first formula, that is mole is equal to given mass over molar mass. Okay, so given mass already is 25 gram. And what about the molar mass? If you calculate the molar mass of NaOH, Na is 23, O is how much? 16. And then H is 1. So how much? 40. So what will be the number of moles? It is 0.625. Right? Now I can use this value over here. So 0.625 moles, how I can get? What will be the concentration? Just divide this value now here, 0.5. You will know the concentration. Because volume is multiply here, so when it will move this side, it will be divided. So 0.625 divided by 0.5, what you are going to get? 1.25 mole. So that is the right answer. Can you get this option? Yes, the option C is the right option here. So I hope this is clear to you that where you have to use which formula. According to the information given in the question, it will be easy for you to predict which formula you are going to use. But there are only 3 formulas for the mole that you have to choose which one you can use, okay? So you just have to remember the 3 formulas for the mole. So option C is the right option. Now let's see another example. What is the volume of 14.5 gram of gaseous butane? So see, they're asking about now the gaseous one because we have 2 formulas that contain volume. The first formula, the second formula of the mole is concentration into volume, right? And the third formula is mole is equal to volume over 24 dm cube. So both have the word volume in them, right? But you have to decide which one we have to use now. Because they are talking about gaseous butane, it means we have to use this formula because they are talking about the gas. This formula is related to gas. Now we have to find the volume. This one we already know, but mole information is missing. So what we can do now, we have to find that which information is given to us now. Can you see any information? Yes, we are already given the information 14.5 gram. So it means it's the solid information. So the first formula will be used now. Mole is equal to given mass our molar mass, right? So what is the mass of the butane? You can just calculate. It is 58 gram, right? And given mass is 14.5. So now what are the number of moles? It is 0.25. So we can put this value over here, 0.25, and then this 24 is dividing over here. It will, when come here, it will be multiplied. So 0.25 into 24 is 6 dm cube. So the answer is 6 dm cube. Can you find 6 dm cube? Yes, the option D is the right option. So you can see we are just using the same three formulas again and again according to the scenario. So here we have used the first formula and the third formula, okay, of the moles. So I hope this point is clear to you now, that how we can use or how we can calculate the questions related to chapter 5. Only you have to remember the three formulas and just use your brain that which formula will be you will be using in the particular question. So option D is right over here. So these were all the questions that were related to chapter 5, and some of the tricks I have given you that you have to remember for chapter 5. Now let's see chapter 6, electrochemistry. I will give you some example of the question and I will tell you what are the common mistakes the student usually do in chapter 6. Now let's see one by one. First question, which statement about electrolysis is correct? So to answer such question, you have to remember the basics of electrolysis. First, you should know what is electrolysis, okay? Electrolysis is actually, you can remember from the word electro means electricity, lysis means breakdown. So it is the breakdown of any compound, usually ionic compounds, by the use of electricity, okay? So the breakdown of ionic compounds using electricity is called electrolysis. Now what is the electrolytic cell? You have to remember the basics of the electrolytic cell. It always have one cathode, okay, and an anode. These are the electrodes. Anode is always positive charge, cathode is a negative charge, okay? Now, if it is a negative charge, so from the electrolyte, we have an electrolyte. What is electrolyte? It is actually an ionic compound that will be broken down using electricity, okay? So electrolyte will produce two types of ions, positive ions and negative ions. The positive ions will be moving towards the electrode that has an opposite charge. So positive ions will move towards the cathode because cathode is negative charge, whereas negative ions will move towards the anode because it is a positive charge. So you have to remember these things for the electrolytic cells. Otherwise, you will get confused in the exam. So this is how the ions are moving in an electrolyte. Another important thing you have to remember that we also have an external circuit here outside, okay? And in external circuit, we have the positive and the negative terminals. And in external circuit, electrons are actually moving, okay? So electrons don't move inside an electrolyte. It's only the ions are moving inside an electrolyte. The electrons always moves in the external circuit. This is the biggest mistake the student usually do for electrons. They think that electrons are moving inside the electrolyte. That is wrong. Electrons always move in the external circuit and the direction is towards the cathode, okay? Remember that direction is towards the cathode. That's why cathode is negatively charged. Why negatively charged? Because it has electrons. That's why electrons are moving towards the cathode. So remember that electrons move in the external circuit and towards the cathode. So if you see which statement about electrolysis is correct, electrons move through the electrolyte. Wrong. They always moves in the external circuit, okay? No need to read this one. Electrons move in the external circuit. Yes, right. Towards the cathode? Yes, that's right. So option B is the right option. Let's see now C and D. Negative ions move in the external circuit. Again, wrong. Ions always move in the electrolyte. Positive ions move through the electrolyte. Yes, that's right. But the option towards the anode is wrong. Why? Because positive ions will always move towards the negative electrode, that is cathode, and anode is positive. So that's why option D is the wrong option. So we are only left with option B, that is correct. See now, okay, now we will look at the products, which products we can get at the cathode and anode depending on our electrolyte. So whenever you see the word molten, so it means your electrolyte products at the cathode and anode will be same like your electrolyte. What does it mean? It means the ions that are present in that electrolyte. What is our electrolyte here? Sodium chloride. It means your product will be same, sodium and chlorine. Okay, if you see the word molten, then the product will be same as your compound. One will be sodium and the other one will be a chlorine gas. Chlorine is a non-metal. Non-metal are always negative ions, so it means chlorine will move towards the anode because anode is positive, right? So at the anode you will get the chlorine gas, whereas the at the cathode, because cathode is negatively charged, right? So at cathode you will get the metal, and that is sodium. The positive ions you will get at that. So that's why the sodium you will get at the cathode, and at anode you are going to get chlorine. So this is simple. Okay, so if the word is molten, then you are going to get your own anions and cations, that is sodium and chlorine. So option D is the right option. Okay, let's see this question. Electrolysis is carried out in a dilute aqueous potassium bromide. Okay, so now we have a solution. Okay, and the solution is how we know that it is a solution, because they use the word aqueous here, right? So whenever you have a solution and that electrolyte is not in the molten form, so for solution always at the cathode you are going to get hydrogen. Remember that in solution form, you will always get hydrogen as a product at the cathode. The exceptional case is only for the copper. In copper sulfate solution, or maybe the silver solution, you will, or AgSO4, you will never get hydrogen. Okay. But all other option, if you see the word aqueous or you see the word solution, the cathode product will always be hydrogen. So can you see the product of the cathode? It's hydrogen. So it means this option is the only right option here. Okay, so you can directly choose the option A, or if you still want to know about the anode, so for anode, remember that it depends on the concentration. It don't depend on the solution. First, it should be a solution, and the second is the concentration you also have to look for. If the concentration is dilute, okay, they are already telling you that dilute aqueous potassium bromide. What does it mean? If the solution is dilute, you are not going to get your own bromide ion here, not the bromine gas. Why not bromine gas? Because this one is dilute. You are going to get now oxygen here. Why oxygen? Because the aqueous solution, if you remember, we have water. So we have hydrogen ions, we have hydroxide ions, and then we have potassium ions, and then bromide ions, right? So these will move towards the anode. Who will move towards the anode? These two, and these can move towards the cathode. But in the presence of hydrogen ions, the metal cannot move towards the cathode. That's why you will get a hydrogen gas at the cathode, okay? Now let's come for the anode. In the presence of the bromide ions or hydrogen ions, it only, or hydroxide ion, it only depends upon the concentration. If the concentration is dilute, these ions will move towards the anode and you will get oxygen as a product. But if it is a concentrated, then you will get your own ions. The anions will move towards the anode and you will get a bromine gas here, okay, or bromine solution here. So if you see over here, we have anode. At the anode, it should be an oxygen. But because we don't have any option for the oxygen, so bromine is the only leftover option. So option A is the right option over here. Let's see another example. The diagram shows the electrolysis of concentrated aqueous sodium chloride. Again, you have seen the word aqueous. It means it is a solution. So what you are going to get at the cathode? It's simple. You are going to get at cathode hydrogen, right? At cathode, it will always be hydrogen as a product if you have an aqueous solution. Exceptional case is copper sulfate or copper chloride. If there is any compound of copper or maybe silver, okay, these two are the exceptional cases. But in all other solutions, you are going to get hydrogen at the cathode. Now let's see for the anode. Anode, I already told you, it will be decided on the base of the concentration. If the concentration is high, it is like concentrated, then you are going to get your own anion at the anode. So if you see here, sodium is positive, chloride is negative ion, right? So negative ion will move towards the anode, or maybe the OH ions can move towards the anode. So now you have to see the concentration. The concentration of sodium chloride is concentrated. It is not dilute, right? So if it is not dilute, you are not going to get the OH here. So only your own anions will come here, that is chloride, right? So chloride ions will come and you will get a product chlorine gas, okay? So now what will be your product at the anode? It will be a chlorine gas, okay? And at the cathode, it will be a hydrogen gas, okay? So option A is the right option for this question. Let's see another example, and that is now copper sulfate. That is an exceptional case. I already told you that copper sulfate, or if you see the silver sulfate or silver chloride, these are the two exceptional cases for copper and silver because they are the least reactive. So now what you are going to get at the cathode, if the solution is copper sulfate, you can see over here. So at cathode, you will never get now hydrogen even if it is a solution. Yes, but because this is copper sulfate solution, so at cathode you will always get your own positive ion. The positive ion is copper, so when it will come here, it will become a metal here, okay? It will reduce and becomes a metal again. So at cathode you will get the copper metal. Always if you see the copper sulfate solution or copper chloride or silver chloride, you are going to get your own metal there, okay? That can be silver or copper. So now at the cathode, we are always going to get copper metal, okay? I hope this is clear to you. Now for anode, we have to look for three things. First, concentration. Second, it should be aqueous. And the third thing is the electrodes. Which type of electrodes are used? So here the electrodes are used carbon electrodes. It means it's simple. You don't have to think more now. It's just if it is carbon electrodes, so you just have to look for this one. Now we have aqueous copper sulfate. So anode, at the anode, you are going to get oxygen. Why oxygen? Here you can say that it is not mentioned it is dilute or it is concentrated. So how we decided oxygen? Whenever you see the word sulfate with copper, oxygen will be the product at the anode. Even if it is dilute or it is concentrated, the product will always be oxygen if we have carbon electrodes, okay? Carbon electrodes and also the sulfate solution. So you are going to get oxygen at the anode. Okay, if I change this one copper sulfate to copper chloride, then what you are going to get? Copper, of course, at the cathode, and chlorine depends on dilute or concentrated. If it is dilute, you are going to get oxygen. But if it is concentrated, then you are going to get chlorine gas at the anode, okay? So only concentrated will get your anions at the anode. So now which option is right over here? You are going to get copper metal and oxygen. So option A is the, no, not, okay, negative electrode. So not option A. At positive electrode, we are going to get oxygen. Yes, option C. And negative electrodes is cathode, so we are going to get copper metal. So option C is the right option over here. Question 36. Again, which of the following correctly describe the products at the cathode and anode during the electrolysis of aqueous copper sulfate using copper electrodes? Right now we have copper electrodes and the solution is same, copper sulfate. And I already told you, whenever you see a copper sulfate solution or copper chloride, anything that has copper in it, then your cathode will always have copper, okay? The product will be copper metal. So can you find at cathode what is the copper deposited? Copper dissolved. So this is wrong. Copper will be deposited there, okay? So at cathode, the copper will be deposited. So this option is the right option. Now let's see for the anode. At anode, if you have carbon electrodes if you have at the anode, then you are going to get oxygen, right? Because this is sulfate. But if you have copper electrodes, then your product is defined already. Your product will always be copper ions. Copper, because electrode is anode is made up of copper, so it will oxidize itself and it will change into what? It will change into copper ions, right? So it means it will get dissolved. So that's why at anode, the copper will always dissolve when the copper electrodes are used. It does not matter which product or which electrolyte you are using. Even if it is copper chloride, still the anode will be this one. The anode product will be copper ions, okay? So if you are using copper electrodes, then the cathode and anode answer is already defined. What will be the product at cathode? It will be a copper metal. At anode, it will be copper ions. Okay, copper ions will be the product. So if you are using copper electrodes, so option A is the right option over here. Strong, the option A is the right option because we are using the copper electrodes. Okay. Now let's see question 37. What are the products at each electrode during the electrolysis of aqueous copper chloride using carbon electrodes? Okay, so now they are using carbon electrodes and we have to look for aqueous copper chloride. I already have informed you that when you will see the word copper at the cathode, it will always be copper, right? So can you see at the cathode which option can be right? So option B or C or D, any option can be right. Now let's see for anode. If you have a chloride gas here, right? Copper chloride. Chloride is already here and you are using an aqueous solution of the copper chloride using the carbon electrodes. And they have not mentioned it that it is dilute. So it means it is concentrated actually, okay? So what you are going to get at the anode, your same chloride ions, right? So at anode, what you are going to get? You are going to get chlorine gas as a product. The chlorine ions will come over here and then they will change, they will lose the electrons and become a chlorine gas. Okay, so chloride ions will move at the anode and become a chlorine gas. If the solution is aqueous copper chloride, it is not diluted. So when the solution is not diluted at anode, you will get your own anions. The negative ions will move towards the anode. And what are the negative ions? That are chloride ions. Okay, so you are going to get chlorine gas at this point. So which option is right? Option C. At cathode you are going to get copper and at the anode you are going to get chlorine gas. I hope these points are clear to you. So you have to remember that if anything is molten, what are the products you are going to get at cathode and anode? Same, your anions and cations. Okay, but if you have aqueous solutions, you are always going to get hydrogen at the cathode except for copper electrolytes. Okay, and at the anode it will depend on the concentration. If it is concentrated, you are going to get your own anions at the anode, that are negative charge particles. Okay, they will be converted into gas or maybe anything else. Okay, but if you have a dilute solution, then you are going to get oxygen at the anode always. Okay, but if you have copper electrodes and your electrolyte is also made up of copper, then your product will always be at the cathode is a metal, that is copper, and at the anode it will be a copper ion. Okay, copper ions if the electrodes are made up of copper and the electrolyte is also a copper solution. Okay, Let's see question 38. An object is electroplated with silver using an aqueous silver salt as the electrolyte. Which row is correct? So for electroplating, you have to remember this always, that the cathode will always be made up of an object that you want to electroplate. Here, an object is electroplated, so means your object should be at the cathode, because you have to electroplate an object. This object can be anything, so your object should be at the cathode. And and any metal you want to deposit, it should be at the anode, because usually the anode will be oxidized. It will change into ions. It will get dissolved. So anode should be your metal that you want to deposit. If you see here, an object is electroplated with silver, it means silver is the metal you want to deposit on that object. So your silver should always be at the anode. Okay, so silver should be at the anode. So the other electrode is made from what? Silver, because silver is the one that you want to deposit. But what about the object you want to electroplate? It should be at the cathode. So cathode is the right option. So this option D is correct. Cathode is made up of the object you want to electroplate and the anode. The other one, the other electrode is actually now the anode. And anode will always be made up of the object that you want to use for electroplating. So here we have to use silver for electroplating. This question is only related to electroplating, in which your anode should be made up of the metal that you want to deposit, and the cathode should be made up of the thing that you want the electroplating. Okay, it can be iron if you want to do the electroplating of iron with silver. So just put the iron at the cathode, and at the anode it should be silver. Okay, and what about the electrolyte solution? It will always be the same like an anode. If your anode is made up of silver, then your electrolyte solution should be any salt or any solution of silver, okay, not of iron. I hope this point is clear to you. So these are some of the questions that mostly students find it difficult in the exam, and they do the mistakes, okay, related to chapter 6. So now we will see some of the common mistakes usually students do in chapter 7 at chemical energetics, and what are the tricks and how you can tackle these mistakes in your exam. Let's see one by one. Okay, first, which process involves a chemical change? Most of the students already know that what is a chemical change and what is a physical change, but the common mistake they usually do in this question, when they are given with the option of adding sodium to water and dissolving sodium chloride in water, they forget that sodium is a metal and sodium chloride is an ionic compound, it is a salt. Okay, so they just think that okay, both options are actually not the chemical change, they are physical change. No, please read the question carefully. This is a sodium metal, and metals don't dissolve in water, they actually react with water, they form a new compound with water. So that's why adding sodium in water is a chemical change. Adding sodium chloride in water, it is a physical change. Okay, but sodium in water is a chemical change. So that's why option A is the right option. Let's see question 41. Again, a gas is produced when calcium carbonate is heated. Which type of change is this one? So sometimes the student usually forget that okay, which option should I choose? Should I choose exothermic or separation or whatever? Please, they are asking about a change. So there are only two types of changes, physical change and chemical change. They are not asking about the type of the reaction. So you can just look at this one. A gas is produced, it means something new has been made. Gas is produced means that now you get a new compound. So this change will be a chemical change. So that's why option A will be the right option. Okay. Let's see another question. 10 gram of ammonium nitrate are added to water at 25 degrees Celsius and the mixture was stirred. The ammonium nitrate dissolved, and for 1 minute the temperature of the solution is 10 degrees Celsius. Okay. So now you already know the difference between chemical change and physical change. Now there is another important concept, that is endothermic and exothermic. Students usually get confused even if they know the answer. They know that exo means the exit of heat, right? Exit of heat means the surrounding temperature will be higher now. higher. And for endothermic, they think that surrounding temperature will be lower, right? But the biggest mistake they usually do, they don't consider solution as a surrounding. They think that solution is actually not a surrounding. So in exam, if they tell you that, okay, the water is, ammonium nitrate was added to the water, the temperature was 25. Later, the temperature of the solution changed to 10. So they think, okay, the temperature of the solution is 10. So what does it mean? It means it's an exothermic reaction. Why? Because all the heat is given out. Now that's why the temperature of the solution is reduced. That is wrong. Solution is actually your surrounding. How you will know that this is surrounding? They are asking about surrounding. The simplest trick is read the question, and if the word is temperature, then it means they are talking about surrounding. Even they tell you that the temperature of water, you see, water is our reactant in this, but still you cannot choose it as exothermic. Temperature was 25, then it becomes 10, so the temperature is reduced. It means all the surrounding temperature has been reduced. So in endothermic, the surrounding temperature will be lower. So this reaction is endothermic. You just have to look at the word temperature. If the temperature word is used, it means they are talking about surrounding, not about the solution or the reaction mixture inside. Okay, these all things are actually your surrounding. Even your reaction mixture is a surrounding. So if you see the word temperature and it is reducing, it means it is endothermic, because they are talking about the surrounding. So which option is right? Option A is the correct option. Let's see another example. When ammonium nitrate is added to water, the temperature of the water decreases. Again, the student will think, okay, the water temperature has decreased. What does it mean? It means all the heat is given out, right? So it is exothermic. No. If you see the word, again I'm telling you, the temperature word, it means they are talking about the surrounding. So if the temperature of the surrounding, it means they are talking about surrounding, it decreased. So now the reaction is actually endothermic. Okay, so which explain these observation? First, the ammonium nitrate dissolve in the water, it reacts with the water. But first of all, let's see the temperature of the water decrease. So it means it's an endothermic reaction. So these two options are right. The process is endothermic. Now let's see another information. The ammonium nitrate can be recovered by evaporating the water added. So what does it mean? It means you can get back your ammonium nitrate, right? So this solution is actually not a chemical change. It is a physical change. Why? Because you just have to do the evaporation process. You don't have to do any other chemical reaction. It's just you have to evaporate the water, just do the process of evaporation. So what you are going to get? You are going to get ammonium nitrate, right? You can get back your ammonium nitrate solid. So this reaction is what? The ammonium nitrate is dissolved in water. It has not reacted with water, because if it has reacted with water, you cannot get back ammonium nitrate just by evaporation. Okay, so evaporation, if it is giving you back your own reactant, then it means it's a physical change, and physical change is actually like dissolving in the water. So option A is the right option. 44. The initial and final temperature of four different reactions are measured. Which reaction is the least exothermic? Okay, now the students already know that initial temperature and final temperature difference. They can just calculate. If you see here, the difference is 6, right? If you see here, the difference is 3 maybe. If you see the difference here, maybe 5. Okay, I'm just calculating. I'm not calculating. I'm just letting you know. Maybe, yeah, okay. And this is 4. And the student will choose what? Least exothermic. It means this is the right option. Wrong. You don't have to choose like randomly by just finding the difference. First of all, you have to, because they are asking about exothermic, they are not asking about the difference. So first you have to see which one of them are exothermic, which reactions are exothermic. So remember that in exothermic reaction, the final temperature, surrounding temperature should be higher. Okay, initial should be lower and the final should be higher. So if you look over here, the initial was 19, final is 25. It means the high surrounding temperature has been increased. So this is exothermic. Now let's see any other option. 21, 18, it is reduced. This one is not exothermic. 22 was the starting and the final is 17, not exothermic. 22 was the starting one and the final is 26. It means it has been increased, right? The surrounding temperature has increased. So these two are actually exothermic. So now you have to decide which one is the least one. Now you have to calculate the difference. If the difference is less, the one which has a less difference, it means it is the least exothermic. So 25 minus 19, the answer is 6, okay? So the 6 is the answer, whereas this, the answer is 4. So it means which one is the least exothermic? It is the option D, because the answer is 4, okay? So option D is the right answer. So first you have to find which of these reactions are exothermic, and then you have to calculate the difference, okay? So that's why option D is the right option. Question 45. Which statement about exothermic and endothermic reactions are correct? Already I told you, students already know that exothermic means that the heat is given out. But they get confused with some of the statements like C. During an exothermic reaction, heat is given out. Yes, that's right. The temperature of endothermic reaction goes up because heat is taken in. The student will think, yes, that's right. Why? Because endothermic reactions always take in the heat. But that's not the temperature. The temperature of endothermic reaction will not. Temperature is for the surrounding, okay? The heat of endothermic reaction actually goes up, right? So that's why you cannot use the word temperature for the reaction. The reaction heat is actually higher, okay, not the temperature. The temperature is actually for the surrounding world. So surrounding temperature never goes up for endothermic reaction. So that's why this option is wrong. Okay, temperature is always lower because the heat is taken in. So now third option, burning methane. Methane, we already know it's a natural gas. It's a part of natural gas. So whenever you are burning a fuel, it's a fuel. So the reactions are always exothermic. They give a lot of heat. So option 1 and 3 are the right option. That is the option C. Okay. So option C is the only correct option. Let's see for 46. Which statement defines the activation energy? All the students know that it is the amount of energy that is needed to start a reaction, but the biggest mistake the student usually do, they forget that this energy is maximum or minimum. Sometimes the student choose the word maximum. That is wrong. It is not the maximum amount of energy. It is actually the minimum amount of energy that the particles must have to react. Okay, so that's why option A is the right option. So it is the minimum amount of energy that the reacting particles must have to react. So option A is the right option. Okay. So many students get confused with reaction pathway diagram, and at least you will get one question related to reaction pathway diagram. So for this one, there are some tricks that you have to remember. Okay, you can practice for that. And how you can, which diagrams is correctly labeled. First of all, you have to see the labeling. Always I will show you that what does labeling means and how it is. It is same for endo and exo. Delta H is one of the important component of this diagram. Okay, how you know what is delta H? It is always between reactant and product. Wherever the reactant and product word is written, it will be delta H. The space between reactant and product is actually your delta H. Okay, so can you see here, this is your reactant, this is your product. So the space between it is actually delta H. So this option is right. Let's see here, reactant and products. No, this is wrong because it is coming from the top. So this means it's wrong. Reactant and product, it should be delta H. So now this is also wrong. Reactant and product, it's always between the space. So this one is right. So these two options are right. Okay. Another important thing you have to remember about the arrow sign. Okay, the arrow sign for exothermic is always like this, downwards. For endo, it is always upward. Why upward? Because upward is showing that it is taken in. Downward is showing that it is released. Okay, in exothermic, the heat is actually released. So that's why delta H is always negative for exothermic, and the arrow sign is always toward the downside. Can you see it is down? It is down. So it means this is also right. Now let's see about activation energy. And another important component or another important part of this diagram is EA. Remember that EA, even if the reaction is endothermic or exothermic, EA is always between the reactant and the top of this diagram. Okay, the top of this arrow. So for example, this is, so from here, this is your picture, okay, or this is reaction. So this is your EA. So EA is always from reactant to the top of the diagram. So can you see here, reactant to the top is always EA. So this is right. Reactant to the top is EA. Yes, that is also right. Reactant to the top is EA. That is wrong now. Okay, this is delta H, so it's wrong. Reactant to the top is always EA. So that's also right. But we can see here now, these two options are still right. So now what is the difference? Which is wrong? Here you can see for EA, it is always upward because EA is actually endothermic. EA, you need the energy. So for endothermic, you see the arrows are always upward. Even if a reaction is exothermic or endothermic, EA is always positive and the arrow should always be upward because it is moving from reactant to the top, right? So the arrow should be like this, towards the top. Arrow should be towards the top, but it is wrong. Can you see the arrow is downward? So that's why option A is the only right option in this picture. Okay, so I hope this is clear to you. What is delta H? Delta H is always between reactant and product, both in exo and endo. Okay, and EA is always from reactant to the top, both in exo and endo, and the arrow should always be upward for EA, activation energy. For delta H, the arrow should always be upward for endothermic, but for exothermic, it should always be downwards. Okay, so that's why option A is the right option over here. Let's see another example of the reaction pathway diagram and how you can differentiate now between exothermic and endothermic diagrams. Okay, if you see here, two reaction pathway diagrams are shown. Which arrow represent the activation energy? Here you have to find. And for a reaction which release the thermal energy, I already told you activation energy is the energy that is required to break the bonds, right? So it will start from reactants to the top. So reactants to the top, this is your reactant and this is the top. So A is your activation energy. Reactant to the top, C is your activation energy, right? Now, which option is right, A or C? This one you have to decide on the base of the endo or exothermic reaction, right? And they say a reaction which release the thermal energy. So which reaction release the thermal energy? Of course, these are exothermic reaction. Exo means exit. Out of the heat is given out. So this means they are talking about exothermic reaction. So for this purpose, you must need to know the difference between exothermic pictures and endothermic pictures. Exothermic pictures, you will always find that the reactants are on the top and the products are at the bottom. Why? Because all the heat is given out. So that's why your products have lower energy level in exothermic reaction. Can you find here now which one has lower energy level? Reactant or the product. So from the 0 point, whenever a thing is starting, this is now your reactant, right? It is starting at the 0 level. So this is your reactant, this is your product. Now this is your reactant and this is your product. Which product is at lower energy level? If you see, the product here is lower energy level, reactants are at the top energy level. So it means this picture is actually for exothermic reaction. So option A is the right option for this question. I hope this is clear to you that what is the difference between exothermic picture and the endothermic picture. Again, let's see this question. The energy level diagram for a reaction is shown. Which row is correct? First of all, let's define this diagram. Is it endothermic diagram or exothermic? If you see, the reactants are below and products are at the top, it means, what does it mean? And if you see, the delta H also direction is upwards, so it means this is endothermic picture. Why? Because the products are at higher energy level, reactants are at lower energy level, they gain a lot of energy, and then Now the products have not released much energy, so that's why the products have more energy, and they are, this diagram is of endothermic. Now it's already decided endothermic, so option B or C can be right. Let's see now for the sign of delta H. The sign for delta H, if you see the arrows are upwards, so sign for delta H for endothermic reaction is always positive. Okay, so positive sign for the delta H is positive. Both options are right. Now let's see for activation energy. Activation energy, the arrows are always upward, so it will be also positive. Activation energy sign is always positive both for endothermic and exothermic reaction. So that's why option B is the right option. Let's see another example of the question and see which diagram is this. The energy level diagram for a reaction is shown. Which row is correct? Now, if you see, your reactants are at the top and the product is at the bottom. So this reaction is actually for exothermic now because all the heat is given out. So now your products are at lower energy level. So first of all, we have to find where the exothermic is written. Yes, this one is exothermic. A or D option can be right. Now let's see for delta H. If you see the delta H row is downward, it means it is negative. Delta H is always negative for the exothermic reaction. Why negative? Because all the heat is given out. Now the system has less heat. So that's why delta H will be negative. So can you see delta H is negative? What about activation energy? I already have told you that activation energy for endothermic and exothermic reaction will always be positive because the arrow is upward, right? In endothermic, it's also upward. In exothermic, it is also upward. So the delta H will be still positive for exothermic reaction. So the option D is the right option. Let's see another question. This is a must question in exam in which you have to calculate the bond energies. And when you have to calculate the bond energy, it has nothing to do with the diagram picture, okay? The bond energy formula is different. Your answer for exothermic reaction should always be negative. And for your endothermic reaction, it should always be positive. How you can calculate delta H? The formula for calculating the bond energy is, you have to remember that the bond energy of the reactants, okay, minus the bond energy of the product. This is the formula you have to use, and you have to calculate the bond energies. The biggest mistake, the students usually know that they know the formula, but when they are calculating, they use the wrong values. How they use the wrong values? Because they misinterpret that how many bonds are present here. So to find the right number of bonds, you have to draw the structure formula. Only structure formula can help you to decide the number of bonds and the type of bond. For example, if you have CH4, then you have to draw the structure. C is 1 and we have 4H. So how many CH bonds we have? 1, 2, 3, 4. Okay, so now you have 4 CH bonds. This is CH, 4, 1, 2 into 4. Oxygen. Now let's see for oxygen. The students usually don't know how to make the oxygen structure O2. I already told you, whenever you are drawing the structure formula, you have to remember the oxidation state. So oxygen needs 2 electrons to complete its outermost shell. It has oxidation state 2, so it means it will make double bond. So that's why oxygen and oxygen will have a double bond. And how many oxygen you have now here? 2. So it means you have 1 bond and this is 2. So total 2 oxygen bonds you have, that is 498. Sometimes the student miss this coefficient and they do a lot of mistake. Don't forget these coefficients. 498 into 2 will be the right answer. So when you calculate, this is the bond energy of the reactant, okay? What about the product? Again, if you look at the carbon dioxide, you have to draw the structure and you have to complete the electronic configuration. Carbon always make 4 bonds. Oxygen always make 2 bonds. So this is the right structure. So carbon double bond, how many you have? 2. Okay. So you have 2 carbon double bond, that is 743 into 2. And then how many OH bond you have? In H2O, if you see, the structure is like HOH. Oxygen is making two bonds, right? One, two. Hydrogen is just making one bond. This hydrogen is also making one bond. So this is the right structure formula for water. But if you see, we have two water molecules. So how many OH bonds we have? One, two, and this is two. Two twos are four. So total we have four OH bonds. So your answer should be 4 into 463 and then plus 743 into 2. So this value will come here and this one will come here. Okay, this one will come here and this one will come here. So then you can calculate the difference and you will know the right answer. So please always draw the structure formulas for calculating the right answers. Otherwise, you can do any mistake in the calculation and your answer will be totally different. So the right option is here B. Okay, let's see question 52. Hydrogen burns exothermically in oxygen. The equation for the reaction is this. Okay, we can see over here. Again, they have given you bond energies and you have to just calculate the delta H value. What is the energy given out? It means the delta H you have to find. So it is simple. The students already know the formula that delta H is equal to the bond energies of the reactants minus, okay, the product, right? But the common mistake the students will do, they don't know how to draw the structure formula and how to find the bonds, that which bond is present. So first of all, whenever you are writing the bonds, you have to first make the structure formula. If you have H2 here, so it means the bond is HH. That is the structure formula for hydrogen. So how many hydrogens you have now here? Only one hydrogen bond. But if you see here in the coefficient, it is written 2. So it means now you have two hydrogen bonds. Usually the student forget to add the coefficient. So this coefficient must be here. So it means you have 2 into 4 into 3, 6 is HH. And then how many oxygen bonds you have? You have to draw the structure. So only one bond of oxygen. Don't get confused that you have two oxygen, so now you have two bond. No, you have just one double bond of oxygen, that is 498. So this is the bond energy of the reactants. You have to calculate this one. And how you can calculate for the product is simple. You have to look for the structure formula of the water, that is HOH. So it means how many bonds you have? 1, 2. 2 OH bonds you have in one molecule. But what is here? It is written 2 molecules of water. So 2 into 2 means you have 4 OH bonds. So that's why your product is 464 into 4. So please don't forget about the coefficients. The biggest mistake the student usually do is in the coefficients, they forget to write the coefficient and then they don't multiply it with their answer. Second mistake they usually do is that they don't know how to write the structure formula. So be very careful when you are drawing the structure formula. Then you can decide that which bond is present and how many number of the bonds are present. Okay. Then you can exactly calculate the right answer. So the answer for this question is C. You can calculate using these values and you will see your answer will be C. Okay. So remember what you have to remember. Don't forget the coefficients. And the second, always draw the structure formula to know the type and the number of the bonding. Let's see another question. Question 53. Which equation represent an endothermic reaction? So now if the student will look at this question, they will be usually confused at how they will know that which one is endothermic reaction. The biggest trick I will give you for this type of reaction is that endothermic reaction is always about bond breaking. Another thing that you have to remember that all the oxygen reactions are exothermic. So if you see any reaction that is with oxygen molecule, it means it's the burning. And burning reactions are always exothermic. So can you see here oxygen is reacting over here, right? So this is exothermic. This option is excluded. Let's see for this one, the bond making. You are making two bonds between hydrogen and hydrogen. Bond making is always exothermic reactions because a lot of energy is released when the bonds are made. So this option is also now excluded. Another example is the water reaction with the metals. All reactions of water with metals are exothermic. So now you are only left with this one in which the bond is breaking. Bond breaking is always endothermic. If you see, before we have a chlorine-chlorine bond, and now this chlorine becomes an atom. Before it was a molecule, the bond has broken. So whenever the bond breaking take place, it's endothermic reaction. So that's why option A is the right option. So which tricks I have already given you? First, all the oxygen reactions, if you have oxygen molecules, they will be exothermic. All the metal reactions with water, they are also exothermic reactions, okay? And bond making is also exothermic. And what is endothermic? Bond breaking. Bond breaking is endothermic. Photosynthesis reaction is also endothermic. Cooking process is also endothermic reaction. You have to remember some of these reactions. Decomposition reaction, if you see anything is breaking into two, you have one reactant and it give you two product, then that is also endothermic reaction, okay? Remember that decomposition, photosynthesis, cooking, these all are endothermic reaction. Bond breaking, also endothermic reactions. So option A is right for this question. Let's see another question. Which statement about endothermic reactions are correct? So this is related to bond energies. If you see here, the energy of the product is higher or lower, you have to look at that one. And it is related to the energy level diagram. If in exam you don't get energy level diagram, then you will get at least this question that is related to energy level diagram. So before answering this question, and you have to see that they are already giving you the energy of the products, right? So let's see one by one. The energy of the product is greater than the energy of the reactants, endothermic reactions. If you see the energy level diagram, reactants are always at the bottom and products are always at the top in endothermic reactions, right? So it means energy of the product is greater. Yes, it's right. Energy of the product is greater than the energy of the reactant. This option is right. The energy of the reactant is greater than the energy of product. Of course, it is opposite, so it's wrong. The temperature of the surrounding increases during the reaction. That is another thing you have to remember, that in endothermic reaction, the surrounding temperature always decrease. So that's why this option is wrong. The temperature of the surrounding decrease during the reaction. So option 1 and 4 are the right option. That is option B. Okay, so option B is correct. Question 55, which statement describe an exothermic reaction? Now, if you see, the energy absorbed for bond breaking is greater. So now this question is related to breaking the bonds or making the bonds. Bond breaking is always endothermic. Bond breaking is endothermic reaction. So it means for exothermic, the bond breaking should be less, right? Because if bond breaking is more, it means it's an endothermic reaction. So we have to see the energy absorbed for bond breaking is greater. Wrong. For exothermic, it should be less. The energy absorbed for bond breaking is less. Yes, this option is right. The energy released by bond breaking. Again, the statement is wrong because energy is never released when the bonds are broken. The bonds are broken with the help of activation energy, and that energy is actually the energy absorbed, energy taken in to break the bonds. Okay, energy is never released when bonds are breaking, it is only released when bonds are made. So, bond making is exothermic and energy is released, okay, and bond breaking is endothermic. So this option is also wrong. Now let's see the energy released by bond breaking. Again, this statement is wrong. Energy is never released when the bonds are broken, it is always absorbed. So which option we are left with? Option B. The energy absorbed for the bond breaking is less than the energy released by the bond formation. Yes, when the bonds are formed, the energy releases more in exothermic reaction and bond breaking is less. Okay, so that's why option B is the right option for this question. Let's see another question. Which statement about endothermic and exothermic reaction is correct? Again, the same statement about the bond breaking and bond making. For this one, you have to remember that bond breaking is always endothermic. Okay, endothermic. and bond making is exothermic. And how you can remember from this trick, when you are making new friends, then in the start you guys are so excited, you share everything with each other. What does that mean? It means you are so excited, you have more energy, right? So bond making is exothermic. How? Because a lot of heat is given out. So that's why you can just remember from this trick that bond making is always exothermic, because a lot of energy is given out, right? And bond breaking is endothermic, because usually whenever you end your friendship with your friends or someone, what you will do, usually these are like a cold type relations, and then you will end up those relations, right? So the end product is cold. What does it mean? It's endothermic. So you can remember from this that bond breaking is always endothermic and bond making is exothermic. So now we can see the options which are right. In endothermic reaction, less energy is absorbed in bond breaking. Endothermic means bond breaking should be more, right? Bond breaking, so less energy, no, more energy should be absorbed. So that's why this option is wrong. In an endothermic reaction, the activation energy is always higher than in an exothermic reaction. That is wrong. Why? Because the activation energy always depend on different type of reaction. It does not depend on endothermic or exothermic, because activation energy is the minimum energy to start a chemical reaction. So it differs based on the type of the reaction, not on the like endothermic or exothermic. For some reaction of exothermic, it can be very high. For some endothermic reaction, it can be very low. So it depends only on the type of the reaction, not on the base of endothermic or exothermic. Okay, so this option is also wrong. In an exothermic reaction, okay, the more energy is absorbed. Again, wrong. Exothermic reaction always release more energy. They don't absorb more energy. So you don't have to read the complete statement. It's only you just know that okay, more energy is absorbed. It's wrong. In exothermic, more energy is never absorbed. In an exothermic reaction, the reactants are higher on an energy level diagram than the product. Yes, this option is right. If you remember the energy level diagram, the products are always at lower energy level in exothermic reaction, because all the heat is given out, and the reactants have more energy. That's why they are giving the heat, right? So the reactants are higher on their energy level diagram than the products. So option D is the right option. So these were some of the questions that were related to chapter 7. Now I will cover some of the important questions related to chapter 8 that will must come in the exam, and the usually student do some common mistakes in such questions. Let's see now one by one each question. First question, which changes increase the rate of reaction? So the rate of reaction, there are four factors that can increase the rate of reaction. First is the temperature, the second is the pressure, third is the concentration, okay, and fourth is the catalyst. These are the four factors that can increase the rate of reaction. In concentration, you can have two types. Either it can be a surface area, okay, a high surface area for the solid, okay, and for concentration for the liquids, okay. So surface area, if it is higher, then the rate of reaction will also increase. So higher the temperature, higher will be the rate of reaction. Higher the pressure, higher the rate of reaction. High, if you add the catalyst, higher will be the rate of reaction. Higher the concentration, the rate of reaction will be higher. So surface area also higher, then it means the rate of the reaction will increase. So now let's see one by one. Increasing the concentration of the reactants. Yes, that option is right. Increasing the particle size of the solid reactant. What does it mean? If you are increasing the particle size is inversely proportional to the surface area. If you are increasing the size, it means you are decreasing the surface area. So it means if you decrease the surface area, the rate of reaction will also decrease. So this option is not right. Increasing the temperature, yes, right. So option 1 and 3 are only the right option, that is C. Let's see another one. Magnesium reacts with hydrochloric acid to form magnesium chloride and hydrogen. Why does magnesium powder react faster than magnesium ribbon? So if you see what they are asking about magnesium, and magnesium is a solid, right? So for solid, actually the surface area matters. Higher the surface area, higher will be the reaction rate. Okay, so if you see, why does magnesium powder? Because magnesium powder has a higher surface area. That's why the rate of the reaction will be higher, right? So why the rate of the reaction will be higher if there is a large surface area? It means more particles will be exposed. Okay, there will be more particles that will be exposed to other reactant for the reaction. So you see, now we can see the option. The magnesium atoms in the powder have lower, nothing to do with the low activation energy. The powder have a smaller surface area. Again wrong, because the powder has the larger surface area. That's why the reaction has a higher rate of reaction. The magnesium atoms in the powder have more frequent collision with the acid particles. Yes, this option is right. Now they have more particle collision because now they are more exposed to the acid. The acid is another reactant, right? So because you have increased the surface area, so when the surface area is increased, it means now there are more chances of collision with the other reactant. So option C is the right option for this question. Okay, so if you are increasing the concentration or increasing the surface area, the reason behind increase of the rate of reaction is actually the more number of collision. More number of collision will actually result in high rate of reaction in terms of concentration, in terms of increasing the surface area, and also in terms of increasing the pressure. Okay, but for temperature and catalyst, the reason is different. We will see that one. So option C is the right option. Let's see this one. Which change in condition increase the energy of the particles in a reaction? Okay, so which change in conditions can increase the energy of the particles? Now they are not asking about the rate of reaction. They are asking about the energy of the particles. Which factor is actually increasing the energy of the particles? Let's see one by one. Addition of a catalyst has nothing to do with the particles. It is always used to decrease the activation energy of the reaction, not the particles. Activation energy of the reactants. Okay, that's why we add catalyst. Increase in concentration. Increasing the concentration, I already have told you, increasing the concentration, increasing the surface area always increase the rate of collision. Okay, why increase the rate of collision? Because more particles are now exposed to each other. So energy has nothing to do with concentration, with surface area, and also with the pressure. Okay, now the only thing that remain is temperature. Temperature, actually, when you increase the temperature, the kinetic energy of the particles increase. So kinetic energy is actually the particles movement energy. So that's why increasing in temperature is the right answer. That changing the factor, that is temperature, will increase the energy of the particles, and now the particles will collide more successfully with each other and more frequently. So option D is the right option. Whenever you see the word energy, only temperature is responsible for increasing the energy of the particles. Okay, no other factor is responsible. Which change increase the rate of reaction by decreasing the activation energy? So now they are asking about activation energy. They are not asking about the simple energy or the kinetic energy. So activation energy is always decreased by adding a catalyst. Activation energy is not the energy of the particles. It is actually the energy of the reaction system. Okay, so the reaction system has now lower activation energy because of adding a catalyst. So addition of a catalyst is the right option. If you see the word activation energy, decreasing activation energy is only we can get through the addition of a catalyst. Okay, so you have to just choose the option of addition of a catalyst. That is option A. That is the right option. Now let's see another question, and how you can measure the rate of the reaction. The rate of reaction means how quickly a reaction is taking place, and how quickly means what is the time. The time is important. You have to measure the time, actually, that how much time a reaction is taking to finish. Okay, so how you can measure the rate of reaction? Either you can just measure that how much time it has taken to make a new product, or how much time it has taken to absorb or to consume all the reactants. So there are two options. You can either measure the reactants that are consumed, or you can measure how much time has taken to make a new product. Okay, it depends on the situation. So now let's see, they are asking you that which two diagrams show suitable method for investigating the speed of the reaction. So now, for example, in one, what is the reaction? A liquid X react with solid Y to form a gas. Now your product is a gas, right? So if you want to measure a gas, because they are trying to measure a gas here, the product, so your whole apparatus should be accordingly according to that rate of reaction, okay, that you are measuring. So now you are measuring a product that is a gas, so your apparatus should also be the same one. Here we are measuring a gas, right? But there, if you see, when you are measuring a gas, everything should be close, so all the measurements should be right. If you see, when the gas will be formed, what will happen? Some of the gas will evaporate over here, right? When it will evaporate, you cannot get the right volume of your product. So it means this apparatus is wrong. You cannot measure the exact volume of your product at a specific time because they have not used a cock here. Okay, now let's see a second option here. Which option is right? Now they want to measure how much how much of your reactant has been consumed. Why? Because if you see, they are not measuring the gas. They are actually using a balance, and they want to measure that, okay, in start it was 42, the reactant. Now what is the mass at the end of the reaction? What will be the mass? So they want to measure the mass. So for that purpose, they have to add just a cotton wool so that all the gas can evaporate. Once the gas is evaporated, your product has been removed. So now you can see the change in the mass. So once you see the change in the mass, it means you can measure the rate of reaction. So this option is the right option. See another one. Now these two look same, but they always have used a cork, or you can say a stopper. So now the gas will not move out. So the balance will not change any weight. Okay, you cannot see any change in the weight because the product, the reactants, everything is in this beaker now. So how you will know that the reaction has been finished or it has been completed? Because the product is not going out, right? So this option is wrong. Why? Because they have used the stopper. Now let's see this option 4. In option 4, again, they are measuring the product. Now they are not looking at the reactant like in the option 2. So now when they are measuring the product that is a gas, so what are they doing? They are using a stopper. So all the gas just move into this syringe and it don't move out. So it means this is the best technique that you can measure your product. So option 2 or option 4, they both are right to measure the rate of reaction. So that's why option D is the right option here. Let's see another question that is related to the graph. An experiment is carried out for the rate of reaction between HCl and zinc. The result of experiments are shown. What is the label on the y-axis? Okay, remember that I already told you that rate of reaction you can measure either by measuring how many reactants have been consumed per unit time, or how much product is formed per unit time. So now you have two choices. Either you can measure the reactants consumed or the products formed, right? So if you are measuring the product formed, then your graph will always start from 0 to the towards the top. Okay, if it is like this, and for reactant it is always from the top to the bottom, because at the top you have more reactants and slowly they have been consumed. So if the graph is like this, it means they are talking about the reactants. They are actually measuring the reactants now. So can you see in this graph, it is coming from the top towards the bottom. So it means the option can be zinc or HCl. What is the label on the y-axis? It can be either zinc or HCl. Okay. So what is the label on the y-axis? The amount of zinc chloride, of course, wrong option because it's a product, and H2, again wrong. So now we are only left with two options: concentration of HCl and mass of zinc reacted. So if you see, if they say that mass of zinc is reacted, it means they are not talking about what is left behind. They are talking about what has been consumed, right? So the graph will be from top to the bottom. In start, the consume was less and now it is increasing, right? So the graph should be like this, but now the graph is from top to the bottom. How much it is consumed? So it means the concentration of HCl is the right option here. Why? Because once the more we have more HCl in start, and slowly the concentration will decrease because this HCl will be consumed. So that's why option B is the right option here. See another option now. 64. Hydrochloric acid is added to excess calcium carbonate. Don't forget the excess is a very important information, okay? So this one will actually decide your answer. And also you have to look at the graph now. In two different experiments, two different concentration of HCl are used, okay? But the temperature is the same in both experiments. The graph of the results show the volume of carbon dioxide given off over time. So if you see both the graphs, first and second, in one they have used less concentration, in the second they have used more concentration, right? And if you see the volume of the gas is also very high, right? It's different, it's not the same. So it means the reaction is not only affecting the rate of reaction, but it's also affecting the product number. It is also affecting the product volume. What does it means now? The collision rate is higher. We have to see which row. Particles in 2 mole dm cube compared to 1 mole dm cube. Now we have to look for the answers for 2 mole dm cube, okay? So what is happening to the particles in 2 mole dm cube? The collision rate is higher or lower? Of course it is higher because the graph is more steep, right? You are getting more volume of the carbon dioxide and in a smaller time. In small time, like in this much, 1 minute maybe, for example, you are just getting this much steep, but here it is more steeper, right? So it means 2 mole per dm cube concentration has higher collision rate. So option A or B can be right. Now the second option is about collision energy, the energy of the particles with which they are colliding with each other. Is it more or less? It only depends, I already told you, on temperature, okay? So temperature is the main reason behind the collision energy. So if you see, the temperature is the same, they have not changed the temperature, so it means the collision energy was not changed. So option A is the right option, okay? So that's why you have to choose option A. Let's see question 65. An excess of calcium carbonate reacts with dilute HCl. The volume of carbon dioxide produced is measured at regular time intervals. The results are shown in experiment 1. The experiment is repeated with only one change to the reaction conditions. Okay, and we have excess of calcium carbonate here, right? And we are reacting with dilute HCl. So now if you see, which change is made in experiment 2? If you see, experiment 2 is more steeper. What does it mean? It means anything you have added, it is actually increased. You have increased something, that's why the graph is more steeper than experiment 1. It means the rate of reaction is higher in experiment 2, right, than experiment 1. So it means something has been increased in experiment 2. First, the concentration of the acid is increased. If you increase the concentration of an acid, what will happen? Of course, the experiment 2 will have higher rate of reaction, right? So we can choose this option also as an option. Let's see now, the volume of the acid is increased. This option can also be right, okay? The mass of calcium carbonate is increased. This option Y is not right because they already said that excess of calcium carbonate is there. So even if you increase, nothing will change. So excess of calcium carbonate means it cannot be the option because we already have a lot of calcium carbonate. So only thing that is responsible can be either concentration or the volume. The calcium carbonate is powdered. Even if it is powdered, you will see an increase in the rate of reaction, right? So that can also be the option. Now the main thing that will help you to choose the right answer is that these factors actually increase the rate of reaction, right? But if you see over here, these two lines, they are not giving you the same number of the product. The product volume is also different. If the graph was like this, then option A or D could have been right. At the end, the product size should be equal. But here, if you see, the product size is also not equal. The rate of reaction is also higher and the product size is also higher. So it means the only option that can be right here is the volume, because they increase the volume. So now the concentration is also increased and the volume, the number of the particles also increase, so more chances of collision and also there are more number of particles to collide. So that's why you have more volume of carbon dioxide. So the best option should be here is B. It should not be concentration, because if you are choosing concentration, it means that rate of reaction has been increased but there is no difference in the volume. But if you see, there is also a difference in the volume. The product is not the same in experiment 1 and 2. So the option you can choose is volume, okay? Because more will be the number of volume, it means the concentration has also been improved and also now the volume is also improved. So now your rate of reaction will also be more and also your product size will also be bigger. That is the volume of carbon dioxide. So that's why option B is the right option. Let's see 66. The zinc granules are reacted with the excess dilute HCl. The volume of hydrogen given off is measured at different times. The results are shown on graph labeled 1. The result of second experiments are also shown on the graph labeled experiment 2. So excess dilute, so we have dilute HCl is in the excess amount, okay? So which change to the condition was made in experiment 2? If you see, the experiment 2 is less steeper than experiment 1. It means something has been decreased here now, because this one is slower. The rate of the reaction is slower, but the product is same, right? So it means nothing to do with the volume. Now the factors can be temperature, pressure, or concentration or surface area. We can see one by one. The concentration of HCl was decreased. Okay. The second is the size of the zinc granules was decreased. If you decrease the size, the surface area will increase. So if you increase the surface area, the rate of reaction will also increase. But here the rate of reaction has been decreased in experiment 2. So that means this option is wrong. The surface area of the zinc granules was increased. Again wrong, because if you increase the surface area, the experiment 2 will have higher rate of reaction. But here if you see, it is less steep than experiment 1, so the rate of reaction is lower. The temperature was increased. Again wrong, because if temperature was increased, the rate of reaction should also increase and experiment should be B should be here, not at the bottom, right? So it means only option A is the right option. The concentration of HCl was decreased. So when there was a decrease in the concentration, the rate of the reaction also decreased, right? But there was no effect on the volume. I hope this point is clear to you, because the concentration actually is responsible for the rate of the reaction, not related to the product size, that how much product you are going to get. It's usually depend on the volume, okay? If you increase the volume, then you will also get the more product. So option A is the right option here. Question 67. A student add excess magnesium rubber to 10 centimeter cube of 0.45 mole of the sulfuric acid. The hydrogen gas produced is collected and its total volume is measured every 10 seconds. The experiment is repeated with 5 centimeter cube of 0.5 mole dm cube sulfuric acid added to 5 centimeter cube of the water using the same mass of magnesium ribbon. Which line of the graph shows the result of second experiment? So there are so many information given to you already. So what you can do is, first you can find the moles. How many moles of this one are used? If you see, magnesium rubber is 10 centimeter cube and the moles is 0.5. This is the concentration. So how many moles are you have used? The 10 can be converted into dm cube. So 0.001, right, into 0.5. I hope this is clear to you. So now the answer will be how much? 0.001 into 0.5, you will get how much the volume is 0.0005 moles. Okay, first time you use this one, then the experiment is repeated again with 5 centimeter cube of 0.5 mole of the dm cube. So how much is this one now? 5 means it is 0.00. Okay, this one was, wait a minute, 10 into 1000 is 0.01. Okay, this is 0.01. So if you get it here, 0.01 into 0.5, you will get 0.005. Now here we have 0.05, and then when you multiply with 0.5, what you are going to get? 0.005 into 0.5, you are going to get 0.0025 moles. Okay, but if you see, the same volume has changed 5 centimeter cube, and then you added 5 centimeter cube of more water. So what does it means? It means you have added again 0.5 of the water. The volume has added again. So now what will be the moles? 0.005 again. So it means you have same number of the volume. If you see, the volume number is same, but what is the difference now? Here the moles are still 0.0025. So the moles of the second experiment are less as compared to the first experiment. Okay, if you guys are getting confused, I will explain it again. If you see here, just look at the information. The first experiment volume is 10 centimeter, right? The first experiment has 10 centimeter cube as a volume. But the concentration is 0.5 mole. In the second one, the second experiment, you have 5 centimeter cube of volume with the same concentration, that is 0.5 mole, right? But the water is added again. So when the water was added again, the concentration become how much? 0.25. So now the concentration is 0.25, but the volume is same, right? So now the volume is same, but concentration is different. So what will be your answer? Most probably your answer, if you find the number of moles here, what will be the number of moles for first experiment and second experiment? If the number of moles will be less, it means your product will also be less. First experiment will have how much moles? It will be 0. How much? 0.01 into 0.5. So what will be your number of moles? 0.01 into 0.5, you will get 0.005. These are the number of moles for experiment 1. But for experiment 2, if you see, the number of the volume is same, 0.01, but concentration is 0.25, right? So for 0.25 into 0.01, the number of moles will be 0.0025. So it means now the volume of your product will also be different. It should not be same. Okay, the rate of the reaction will also be different, and also the volume will also be different. So these three lines cannot meet each other at the same point. What does it mean? It means you will not get the same number of the product. So it means either this option or this option is right towards the original experiment. Okay, this is the dotted line is our original experiment. Now if you see, which line of the graph shows the second experiment? If you see, the second experiment has lower number of moles compared to first experiment, it means your product will be less. So option D can only be the right option, because the product size is also smaller, the rate of reaction is also less, because the graph is not so steep. So option D is the right option. I hope this point is clear to you. You have to find the number of moles to check that which one will produce more product. Okay, let's see another example of question 68. an excess of calcium carbonate is added to dilute HCl. So now we have excess of calcium carbonate. The carbon dioxide gas is given off and calculated. Its volume recorded at regular time intervals. The line X on the graph shows the result obtained. Okay. The experiment is repeated again using dilute HCl. Line Y on the graph shows the result obtained. Okay. And they both have the same volume, right? It means that only the rate of the reaction has changed. There was no effect on the volume. So now let's see what is the difference. They had the same volume, yes, okay, but the Y had a higher concentration. Is this right or not? If they have the same volume, because they both are dilute, okay, so if they both are dilute, then the volume should be, if the concentration should be higher for Y, right? The Y has a higher concentration. But if the volume is same, then they cannot have the same product size. The product size should be different, right? But here, if they have the volume should also be different. So now let's see, they had the same concentration, but Y had a larger volume. Again, wrong. If Y had a larger volume, the product size will not be the same. Only the rate of the reaction will increase. Okay, so this option is also rejected. Now let's see, X has a higher concentration. Wrong. Why wrong? Because it is less steep. So we cannot read this. Y had a higher concentration. Yes, that's right. Y had a higher concentration. That's why it is, you can see that the speed of the reaction is faster, right? So Y has a higher concentration, but X had a larger volume. Now this option is Y, right? Because if X don't have a larger volume, then the product should also be different. But here the product is same, right? So it means that X is compensating with Y through its volume. It has large volume, but Y has higher concentration. So higher concentration increase the rate of the reaction, but the volume is actually, the Yx has a higher volume, but it is more dilute. So that's why the products are same, but only the rate of reaction is lower. So that's why option D is the only right option over here. Let's see now another example. Powder magnesium carbonate is added to excess dilute HCl. The total volume of the gas is produced over time. The graph of the line is shown here, right? The experiment is repeated, but the concentration of the hydrochloric acid is doubled. All other conditions are kept the same. Which statement about the second experiment are correct? Now let's see again, the HCl concentration is doubled. What does it mean? The rate of the reaction will be increased. Okay, so if you see what is the time taken by this reaction, it's 75 or maybe 90, right here. So the reaction finished before 90 seconds. Yes, the rate of the reaction will be higher now because the concentration is higher. The activation energy of the reaction is lower. That is wrong because concentration has nothing to do with the activation energy. Only a catalyst is responsible for lowering the activation energy of the reactant. So I hope these 2 points are clear. Now let's see the first option. The final volume of a gas is 360. How much is the final volume, total volume of a gas we have over here? We have just here around maybe less than 200, right? Okay, so they already have told you that the experiment was repeated, but all other things were remained the same. All other conditions were kept the same. It means they have not changed anything. They have not increased the volume. They have not increased the temperature. Nothing was increased. Okay, so the final volume of a gas cannot be increased. Okay, so that's why it should not be 360 centimeter cube. That is the wrong option. Why wrong? Because we already have powder, we have just powder magnesium carbonate, and even if it is highly concentrated, you can think that okay, the concentration is more and we have more number of particles, so the product can be more. But the problem is that your other reactant is in excess amount. It is just simply the powder magnesium carbonate. They have not used the word excess with potassium with magnesium carbonate. If magnesium carbonate was excess and the concentration of the HCl was increased, then you can get more volume. But now here you will get the same volume because we don't have more magnesium carbonate. Okay, so that's why option 1 is also not a right option. So only right option is 2. So option D is the right option. Let's see another question that is related to the rate of the reaction and how in a graph you can find that at which time the rate of reaction is the fastest. For example, this question, magnesium is reacted with dilute HCl, the hydrogen gas is collected and its volume is measured. The results are shown in the graph between which time the reaction was fastest. So simply, if you are getting confused, you don't know how to find 0 to 1 minute, you can just try to draw the triangle. Okay, so you can see your triangle is this much, the size is only this much. Now let's see for 1 to 2 minutes. So this is the ending point of 1, so you can draw it from 1 to 2. So now you see this is a little bigger, so this one is bigger. Now for 2 to 3 minutes, so your 2 is ending at this point, so you can draw again the line over here, and you can see this is your 3, this is 4, so this line is like this, right, more bigger. Now from 7 and 8, this is 7 and this is 8. So if you see, this line is straight. So this is the tallest line. It means this from point 2 to 3, it was the reaction was the fastest reaction. That's why option C is the right option. I hope this point is clear to you, that how you can find the speed of the reaction. You can just try to draw the triangles. The triangle that has the longest straight line, it has the longest 90-degree angle. It means that triangle, actually that point is that time is actually the time where the rate of the reaction was the fastest. Now see another one. The volume of a gas given off in a chemical reaction and it is measured over time. The results are shown at which time the rate of the reaction is the fastest. At 0, you see it is just a straight line. At 4 seconds, if you see, we can just measure from here 2 to 4. So the line is this much, right? And from 4 seconds to 6 seconds, if you see here, for 6 seconds, the line will start from here and it will move up till, you can see here, this is your 6. So where it is moving this much, can you see this line? This line is the tallest line over here. But let's see for 10 seconds. So for 10 seconds, if you see, the 8 is here, right? Okay, so from 8 to 10, it is just a very small line. The 90-degree angle is very small, so it means the degree angle of this one, 6 seconds, is the highest, or it is the greatest. So that's why option C is the right option. The rate of reaction at 6 seconds was the highest one. I hope these points are clear to you related to chapter 8, and you already know now some of the tricks. Now let's come towards chapter 9, the reversible reactions and equilibrium. So many students confused with some of the options that are related to chapter 8. So I will explain that which factors are actually related to equilibrium, because the factors that are related to equilibrium position and to the rate of reaction, they are different. Okay, not all of them are same. So now let's see one by one which statement about a reaction in equilibrium is correct. For equilibrium, you need to remember that at equilibrium position, nothing stops, not the formation of reactants or the product. Only the main difference is that in equilibrium, the rate of forward and backward reaction is always same. The rate of reaction is same, not the concentration of the reactant and product. If they ask you about the concentration of reactant and product at equilibrium, it should be constant. You have to use the word constant, okay? So the rate of reaction of forward and reverse will be equal at equilibrium, but the concentration of the reactant and the product will be constant, not equal. So now we can see this option. Which statement about a reaction in equilibrium is correct? Both the forward and backward reaction are proceeding at the same rate. Yes, this option is right. Okay, the rate of forward and backward reaction is equal, so it is equal, it is at the same rate, so that's why this option is right. Why not option B? The forward, not the backward reaction is proceeding. It's wrong. The reaction never stop in equilibrium. It will be a continuous process. So this option is wrong. The amount of the product present is no longer affected by changes in temperature or pressure. Wrong. You can change the position of the equilibrium by changing some factors. And these factors, there are three factors. One is temperature, the other one is pressure, and the third one is concentration. Okay? Not a catalyst. Sometimes the student get confused. They think that catalyst can also change the equilibrium position. That's wrong. They get confused with rate of reaction. Rate of reaction is different thing. Equilibrium position is a different thing. Okay, I will explain to you in the next questions. So the amount of the product present is only affected by change in pressure. Wrong. It's not only affected by change in pressure, it can also be affected by change in concentration or by the temperature. So option A is the right option. Let's see this question. Steam reacts with carbon in an endothermic reaction. Which conditions of temperature and pressure would give the largest yield of hydrogen? Now, the rate of reaction, we already have seen 4 or 5 factors that are responsible for increasing the rate of reaction. So, if you increase those factors, the rate of reaction will be higher. But this is not the case in terms of the equilibrium position. Okay, an equilibrium position increasing and decreasing depends upon the situation. For example, there are 3 factors that can affect the equilibrium position. Okay, these factors are: first is temperature, the second is concentration, and the third one is pressure. Temperature always depend on endothermic and exothermic reaction. We already know that exothermic reaction always release the heat, right? So when they release the heat, it means they don't like high temperatures because their job is to give out the heat. Why they will absorb heat? They don't like to absorb heat. So you cannot give high temperature for exothermic reaction. So if the reaction is exothermic, you have to give a low temperature, so the speed of the reaction will be towards the product. Okay, you will get more yield of your product if the temperature is exothermic. So now let's see this condition. Which conditions of temperature and pressure would give the largest yield of hydrogen? Where is hydrogen? It is our product, and this reaction is endothermic. What does it mean? It means the forward reaction is endothermic. So means for endothermic reaction always like to have high temperature. They like to take the temperature from their surrounding. So it means you have to provide high temperature for endothermic reactions so that you can get more product. Okay, so the temperature should be higher because the reaction is endothermic. So endothermic will always increase the product reaction. Okay, you will get more product. It will change the equilibrium position towards the product, towards the right side if you give high temperature. Okay, so these 2 options can be right. Now let's come towards pressure. Which factor will decide the pressure equilibrium? Like it will move towards left or right? So the thing you have to look for the pressure is that the number of the moles of gases present on the reactant side or on the product sides. If you look here, we have just 1 mole of a solid carbon, right? So it means it's not a gas. You cannot use the pressure for this one. Let's see how much we have gas of water. 1. So 1 mole of water we have here, 1 mole of gas in reactant. And how many moles of gas in the product? 2. 1, 2, right? So the reactants have just 1 mole. The product has 2 moles of a gas. So it means if you increase the pressure, increasing pressure always favor the one that is low in number. And which one is lower? Of course, your reactant. But we have to increase the yield of hydrogen that is actually in the product. So it means you cannot increase the pressure, because if you increase the pressure, the equilibrium will shift towards the left side. Okay, so what will be the conditions now? You have to lower the pressure so that it don't move towards the left side and you just get your more product, that is H2. So lower the pressure will help to get you largest yield of hydrogen. So option B is the right option. Let's see another example so it will be more clear to you. In the Haber process, nitrogen and hydrogen are reacted to make ammonia. The reaction is exothermic, which condition produce higher yield of ammonia. So ammonia is on the right side. So it means we have to shift our equilibrium towards right side to get more ammonia. So we have only two options, the pressure and temperature. So temperature is dependent on exo and endo. They are already have given you information that the reaction is exothermic. What does it mean? It means you have to give a low temperature, because exothermic reactions don't like high temperature, because they are actually giving the temperature to the surroundings. So they will not take high temperature as a option. Okay, so they will always like to have a lower temperature so they can give you more temperature to the surrounding. So that's why the temperature you will be using for exothermic reaction is always lower temperature. So these two options are the right option. Now let's see for the pressure. If you see, the number of moles will decide the pressure. Answer. How many moles of nitrogen we have here? 1. 3 moles of hydrogen. So total 4 moles we have of gas in reactant, and in product we have just 2 moles. So which one is less? It's the product. When the product has lower number of the molecules, right, or the lower number of the moles of the gases, pressure will always help the one that is lower. So who is lower? Of course, it's ammonia gas. The product is lower. So if you increase the pressure, it will help to get you more ammonia, right? And that is actually we want. So maximum yield of ammonia we can get if the temperature is lower and the pressure is higher, because the moles of nitro and NH3 are ammonia are lower. So you can increase the pressure that is high. So option B is the right option. Let's see again another example. Option, this is question 76. Hydrogen gas react with iodine gas to form HI in an equilibrium reaction. Which changes increase the yield of HI at equilibrium? So many students do the mistake by choosing adding a catalyst. I already have told you that catalysts only increase the rate of reaction. It has nothing to do with the equilibrium position. It will only change the equilibrium position of both the sides, so it will not help in the yield. Our target is to get more yield of HI, to get more product of HI. So how we can get more product is only temperature, pressure, and concentration can decide. So this option is not the right option to increase the yield. Adding more hydrogen gas. So if you see, hydrogen gas is in the reactant. So if you increase the concentration of the reactant, you will get more product. And that actually we want, right? So if you increase the concentration of the reactant, the equilibrium will shift towards right side. That's what we want. So option 2 is right. Let's see increasing the pressure. So increasing the pressure always depend on the number of the moles. Which side of the moles have less number of moles? So now, which side of the reactant or product, if you see, we have one reactant, this, and this is one reactant. So total we have 2 mole of the gas in the reactants, and how many product? 2 mole of the product. They both are equal, right? So now even if you increase the pressure or you decrease the pressure, nothing will happen, no change will take place. So it means pressure has now nothing to do in this reaction, because the number of moles are equal. Let's see for temperature. Of course, if you increase the temperature, the rate of reaction will increase, right? But what about the yield? Will the yield of HI will increase? Yes. Why yes? Because if you see, delta H is endothermic, positive. Okay, the reaction is positive, so increasing the temperature will favor the right side. It will help you to get more products. So option 2 and option 4 are the right option, that is option D. Question 77. Hydrogen reacts with iodine to form hydrogen iodide. Which statement explain why the reaction is faster when the pressure is increased at constant temperature? Okay. Now here if you see, the reaction is faster. Now they are talking about the reaction is faster. They are not talking about the product, right? Because the product will not change. It will not move towards the left or right side because on both sides the number of moles are equal, right? But only the reaction rate will increase if you increase the pressure. Increasing pressure always increase the rate of the reaction. And the reason behind is that when you increase the pressure, the volume of the gas will be decreased. So now more particles will come close together and they will have more chance of collision, right? So now let's see where we can find this temperature, this option. At high pressure, the molecules are moving faster. Wrong. Only when you increase the temperature, the particles will move faster because they have more kinetic energy. Okay, so temperature can only speed up the particles movement, or they can it can allow the particles to move faster. So that's why it's only for temperature, not for the pressure. At high pressure, more of the molecules have required the activation energy. Again, wrong. It's only activation energy is actually for the system, it's not of the particles. Okay, so this option is wrong. At high pressure, the molecules are close together. Yes, this option is right because at high pressure, the volume will be decreased. So now more particles will come close together. So option 3 is right. Let's see about the statement 4. At high pressure, the molecules collide more frequently. Yes, because when they come close together, they will collide more frequently. So option 3 and 4 is right. That is option D. So option D is the right option for this question. Okay. 78. Chlorine can be manufactured by the following reaction. The reaction is exothermic. Which change increase the yield of chlorine at equilibrium? So where is chlorine? If you see, it is in the product. So it means they want to shift the equilibrium towards the right side. This is right side and this is left side. Adding more HCl. If we add more HCl, it is in the reactant, right? So the product will be more. So I think this option is the right option now. Because if you are increasing the reactant, you will get more product. Now we can see other option also. Adding more H2O. Wrong. Because if you will add more product, the reaction will shift towards the left side. So that's wrong. Decreasing the pressure. If you decrease the pressure, it will always help the one that is more in number of moles. Let's see how many moles of the gas we have here. 5. How many here we have? 4. So it means if you increase the pressure, it will help the one that is less in number. But if you decrease the pressure, it will help the one that is more in number. So again, it will move towards the left side that we don't want. We want more chlorine. So the reaction should shift towards the right side. Okay. Increasing the temperature. Increasing the temperature always favor the endothermic reaction, but this reaction is exothermic, so it means it will not favor this reaction. It will favor again the left hand side. Okay, so that's why only the option A is the right option. We have to add more HCl so we can get more chlorine in our product. Let's see question 79. Sulfur dioxide is converted to sulfur trioxide in the contact process. Which row describe and explain the effect of changing conditions on the rate of reaction? Okay, they are using different catalysts for 50 temperature. Okay, so if you change the conditions, for example, if you don't add a catalyst, the effect on the rate will be lower. Yes, if you remove the catalyst, the rate of the reaction will be lower. That's right. We will see the explanation later. If you increase the pressure, it will give you a higher rate of reaction. Yes, that's right. If you lower the temperature, the effect on the rate will be lower. Yes, lower temperature will always give you low rate of the reaction. Lower the pressure. If you lower the pressure, the rate of the reaction will be higher. That's wrong. Increasing the pressure always increase the rate of reaction. So this option is wrong. Now let's see the explanation. First explanation, we can start here. Lower temperature, lower the effect on the rate of reaction. Okay, so the rate of reaction will be lower. Why? Because now the particles will have lower energy, right? Because temperature increase the energy of the particles. If you see, what is the explanation? The particles collide more frequently. Wrong. If you're lowering the temperature, the particles will have less energy. Now they cannot collide more frequently. Okay, that's why the rate of the reaction is lower. So this explanation is contradictory with the option C. Now let's see for higher pressure. If you increase the pressure, the rate of the reaction will be higher because the collision will be more, right? The collision will be more. Why? Because there are more particles in the small volume. What is written here? The particles have more kinetic energy. Wrong. Kinetic energy always depends only on temperature, not on high pressure. It only depends on high temperature. Okay, pressure has nothing to do with the energy of the particles. Now we are just left with option A, that is the right option. Why right? Because if you don't add a catalyst, the rate of the reaction will be lower. Why lower? Because catalyst job is to lower the activation energy, right? But now activation energy is higher. Why higher? Because there is no catalyst. So when you remove the catalyst, the activation energy of the reactant will be higher. So now the reaction rate will be lower. So that's why option A is the right option. Okay, I hope this point is clear to you. Let's see another example. The contact process is used to convert sulfur dioxide to sulfur trioxide, and the forward reaction in this equilibrium is exothermic. Okay, so this one is the right side equation is exothermic. Which statement about this process are correct? The catalyst increases the rate of both forward and backward reaction. Yes. The catalyst's job is to just increase the rate of reaction. So if you add it in a reversible reaction, it will always be helping both backward and forward. Okay, so option 1 is right. Option 2, a low pressure increases the yield of sulfur trioxide. Let's see the number of moles. How many moles we have here? 3 moles of the reactant. How many moles of the product we have? Only 2 moles. So if you lower the lower the pressure will always help the one that is more. So it will give you more yield of sulfur dioxide, not sulfur trioxide. Because if you have high pressure, then the sulfur trioxide yield will increase. Because high pressure always help the one that is less in number. So sulfur trioxide is less in number. Okay. So that's why this option is wrong. A low pressure is used to keep the cost low. Yes, that is right. Why we use low pressure in any reaction? Because we want to save the money. Okay, so to keep the cost low, the low pressure is used. Let's see for fourth. A high temperature increase the yield of sulfur trioxide. High temperature can only increase the yield if the reaction is endothermic. But let's see, this reaction is exothermic. So it means the statement is wrong. A low temperature will increase the yield of sulfur trioxide. Okay, you cannot get a high yield. If you can get high rate of the reaction by increasing the temperature, but the yield can never be increased if the reaction is exothermic. So you will always get a lower yield. So which option is the only right option? Option 1 and 3. So option B is the correct option. Let's see another question. Which row identified the pressure and the catalyst used for the conversion of sulfur dioxide to sulfur trioxide in the contact process? So now most of the students will think that, okay, we already know that it's the catalyst for the contact process is vanadium oxide. What is the trick in this question? And the pressure we already know it's 2. But the main mistake the student usually do in the exam, they don't look at the unit of the pressure. So the pressure, if it is given in atm, then 2 is the right answer. 2 atmospheric pressure is the right answer for contact process. But if they give you a unit in kPa, then you cannot choose a 2 option. Then your answer should be 200, because kPa 1 atm is equal to 100 kPa. So 2 atm is equal to 200 kPa. So that's why sometimes the student choose a wrong option, that is D. So please be very careful when you are looking at the unit. You have to look at the unit. The pressure unit is atm, so you have to write 2 is the pressure and vanadium oxide is the catalyst. So B option is right. Otherwise, if they ask you in kPa, then D option will be the right option. Okay, so but in this scenario we have B option is right, because they are asking about the atmospheric pressure, not in kPa. Let's see another question that is related to the chapter 9 and is about fertilizer. Most of the time this question come in exam, but the students usually forget about the what are the three main components of a fertilizer that are very useful for the plant. So for that you have to remember NPK. That's why we call such fertilizer NPK fertilizer, because these are the three important elements that a plant need for its survival or for its growth. N means nitrogen. Okay, it's the symbol of nitrogen. P is the symbol of phosphorus, and K is the symbol of the potassium. So any fertilizer that has nitrogen, phosphorus and potassium, that will be the best fertilizer for the plant. So where we can find all these three, nitrogen, phosphorus and potassium? So it's simple. You have nitrogen here, you have, but you don't have potassium and phosphorus. You have nitrogen here, you have phosphorus here, but no potassium. Potassium, nitrogen, and but no phosphorus. Here potassium, you have nitrogen, and you also have phosphorus. So it means option D is the right option. Again, a same question. Why is the fertilizer described as NPK fertilizer? Okay, a fertilizer containing ammonium nitrate and potassium phosphate. Why we call them NPK fertilizer? It provides nitrogen, which is an essential element for improving the plant. Yes, it provides nitrogen, but NPK don't only provide nitrogen. It provides also phosphorus and potassium. So you have to choose an option that provides everything. It contains the element oxygen. It contains the element nitrogen and phosphorus. But where is potassium? It did not. Now this is, it provides the three main elements needed for the improved plant growth. That's why we call them NPK fertilizer, because it has three elements, N, P and K. So option D is the only right option for this question. I hope these questions are clear to you related to chapter 9. So now we will discuss the questions related to chapter 10 and the most common mistake usually students do in chapter 10, that is redox reaction. So this chapter is related to reduction and oxidation reactions. So let's see one by one. When heated strongly, silicon oxides react with carbon. Which term describe what happens to silicon oxide? If you see, this is your silicon oxide, right? And in the product, what happened? The silicon is just as alone without oxygen. So what does it mean? Oxygen has been removed. So when oxygen is removed, that is called reduction. All those, there are two types of the reaction. One is reduction and the other one is oxidation. If they both takes place in one reaction, such reaction is called redox reaction. Redox reactions are those reactions in which reduction and oxidation is taking place simultaneously. Okay. So now they are not asking about the overall reaction. They are just about asking about silicon dioxide, that what happens to silicon dioxide. So if you see, silicon dioxide has now no oxygen in their product. What does it mean? It means it is reduced. If it gets the oxygen, it is oxidized. If the oxygen is removed, it means that this is a reduction reaction. So option D is the right option. So what is oxidation? What is reduction? You have to remember there are three definitions for oxidation and there are three definitions for reduction. Oxidation is the gain of oxygen, just like the name. Gain of oxygen is oxidation. Then reduction is the opposite, the loss of oxygen. Okay, here we can see the loss of oxygen, that's why it's reduction. The second is, it's the gain of the oxygen, then it means it is actually the loss of electrons. The loss of electrons is called oxidation, and the gain of electrons is reduction. Another term is oxidation number. Because this is oxidation, so increase in oxidation number will be oxidation. Increase in oxidation state or oxidation number actually is oxidation. But if there is decrease in the oxidation number, then it is oxidation. This is called reduction. Okay, decrease in oxidation state or number is called reduction. So everything will be lost in reduction except for the electrons. Okay, electrons will be gained in reduction, but in oxidation we will lose electrons. So now let's see the question related to this one. Which equation represent a redox reaction? So now here you can see there is no involvement of the oxygen. Can you see the oxygen is involved here? Yes, we have oxygen involved. But if you see here Ag, okay, it's a metal, and now it is getting chlorine. It is already losing this nitrate ion, but you have to look for the here now, because the oxygen molecule is not involved. So now you have to look for other two options, either the loss of electron or oxidation state. Okay, so here we will look for the oxidation state, that is more easier. If you see, what is the oxidation state of Ag here? It is +1 and NO3 is -1. If you see in the product, it is still the same. Ag is +1, Cl is -1, here Cl is -1, and this is +1, right? Na is +1, NO3 is minus. So nothing changed, no change in the oxidation state. So this reaction is not a redox reaction. Redox reactions are those reactions in which oxidation and reduction are taking place simultaneously. The trick for such question is that you always should look for the metal displacement reaction or halogen displacement reaction. If you can find the metal displacement reactions, what will be the thing in that? What is the common thing? You cannot waste your time. So what you should do, if you don't want to find the oxidation state, you should look for any equation in which the oxidation state is zero for any element or compound. Okay, not compound, sorry, only for element. If you can find any element in a reaction and that is present in a form of element, like for example, if you see Cl2, so it means its oxidation state is zero. If you find copper, then it means its oxidation state is zero alone. Okay, so can you find any element that is all alone in the reactant? Yes, we have here. That is iron. Can you see it is not present in a form of compound? So it means its oxidation state now here is zero because it is in the element form, right? It is not in a compound form. Now here you can see that does the oxidation state change or not? If the oxidation state has changed, then it means this is the actually a redox reaction. See, the oxidation state of iron is zero here. And now let's see here, how much is this? O4. It means oxygen is -2. So -2 into 4 is equal to -8, right? So Fe3 is also how much? +8, right? It can be +8 because this one is -8. So it means we have the same, we have the oxidation state of the iron here is one is +2 and the other one is +3. So that's why it's 6 and this. So see, the oxidation state before was 0, but now it changed to here. If you see, it changed to +8, right? So oxidation state has been increased, it has changed. When there's a change in the oxidation state, such reactions are called redox reaction. So that's a simple trick. You can find that option C is the right option, okay, in which you can find an element, a reactant in the form of element, or maybe in the product you can find an element. Here you can see you can also find a product that is in the form of element, right? It is just hydrogen molecule, it's not a compound. But before, hydrogen was here in the form of a compound, that is water, right? So that's why option C is the right option. Let's see another example. Which reaction of hydrochloric acid is a redox reaction? Again, you have to look for the element that is present in a compound or in a in the reactant or in the product. If you can find any element, this is a compound, this is also a compound, and here the products are also compound, right? Again, compound, but here you can find an element and then you can find a compound. Here again an element, a compound. So we have, if you see, the oxidation state of magnesium is 0 here, but what is here now? It's +2. So it has been changed, right? So oxidation is taking place here. It means then there should also be reduction. If you see, hydrogen is +1 here, but now it becomes 0, right? So hydrogen is reduced, magnesium is oxidized. So this reaction is actually a redox reaction. So this is the simplest trick if you want to find the redox reaction, first you have to look if you can find any element. Yes, if you don't find any element in any of the option, then you have to find the oxidation states. But if it's already there, any one equation in which elements are present there and also the compound, and later that element changed into a compound, right? The magnesium was element here, but now it changed into a compound. So it means this is actually a redox reaction, and this reaction we usually call it a metal displacement reaction. Okay, or but here it is not a metal displacement reaction, it's just the reaction between a metal and a acid. So that's why metal and acid reactions are also redox reactions. Option D is the right option. Now let's see which row describe what happens to Fe2 plus ions when they are oxidized. So oxidized means the loss of electrons, right? So oxidation means the loss of electrons. So what happens to Fe2 ions? It will lose the electrons. So losing electrons, and if it is oxidized means, then oxidation means the gain of the oxidation number. So the oxidation number of the iron will increase. Okay, oxidation means the increase in oxidation number but the loss of electrons. So option D is the right option here. The equation for the reaction of magnesium with carbon dioxide is shown here. Which statement about this reaction is correct? Let's see one by one. Magnesium is reacting with carbon dioxide, and now magnesium has taken one oxygen. What does it mean? It means when you gain oxygen, you are oxidized. So magnesium is oxidized. What about carbon dioxide? Carbon dioxide has lost its oxygen. So it means carbon dioxide is reduced, right? So now let's see one by one. Magnesium is oxidized, yes, and carbon dioxide is reduced. So this option is the right option. But we can see also other option. Magnesium is reduced, wrong. Why? Because magnesium gained oxygen. Gain oxygen means oxidation. Magnesium and our carbon dioxide both are oxidized, wrong. Magnesium is oxidized, carbon has lost the oxygen, so it is reduced. Magnesium and carbon dioxide are neither oxidized or nor reduced. That's wrong, okay? Because oxidation and reduction, the redox reaction means either you lose an oxygen or gain an oxygen. So this is the first definition that fits for this equation, okay? So that's why option A is the right option. Let's see another example related to the oxidation reduction reactions. Aluminium is extracted by electrolysis. The ionic half equation for the reaction of one of the electrodes is shown. Which row describe the change in oxidation number of aluminium and the type of the reaction at this electrode? First of all, it is the reaction at electrolysis, and we already know at electrolysis we have two types of electrodes. One electrode is positive and the other one is negative. Okay, at negative electrode you will always get the which ions? The positive ions will move towards the negative electrode. So this reaction they have already given you, and you need to remember before the oxidation state of aluminium was 3 plus, right? It's simple, but here now aluminium is in the form of a metal. Now the oxidation are in the element form, so now oxidation state is 0. So oxidation state was higher, it was 3 plus, now it is 0. So what does it mean? This is a reduction reaction because the oxidation state has been decreased. The oxidation number of the change in the oxidation number from 3 plus to 0 means it has been decreased. So these two options are right. Now, what type of reaction is this? When the oxidation number is decreased, it means this is a reduction reaction. Okay, it is the opposite of oxidation. So that's why option A is the right option. Let's see another question. The equation for the reaction between aluminium and copper oxide is shown. Which statement about the equation are correct? Again, let's see here. It's a simple equation. You can easily see that aluminium gained the oxygen. So it means aluminium is oxidized, right? Because it gained the oxygen. This is the definition of oxidation. And copper oxide has reduced. Why? Because the oxygen is removed. So copper oxide is reduced. Now let's see the oxidation. The oxidation number of aluminium reactant is +2. We have to check. Now, aluminium is in the form of the element, right? Whenever anything is present in a form of element or in a form of molecule, but not in a compound, its oxidation state is always zero. So this statement is wrong. The oxidation number of aluminium in the product is +6. Okay. Let's see what is the oxidation state, oxidation number of aluminium. O3 oxygen has a oxidation state of -6 now, because -2 into 3 is equal to -6. So Al2 is +6, right? But this option is wrong. Why? Because we have 2Al2, right? So one aluminium has the oxidation state that is +3. It's not +6. Okay, same is for oxygen. The oxidation state of oxygen here is -2. It's not -6. Okay, overall the charge is -6 because we have 3 oxygen. Overall charge is +6 because we have 2 aluminium, but oxidation state is +3. So this option is also wrong. The oxidation number of the copper in the reactant is +2. How to? Because if oxygen, we already know that oxygen state is -2, right? So it is -2, then copper is +2, right? Because they both are equal in number, 1, 1. So it means this option is right. In the copper, in the reactant, the copper oxidation number is +2. The oxidation number of copper in product is 0. Yes, that is also right, because copper is in the element form now. Okay, anything that is present in the element form or in the molecule form but not in compound, then the oxidation state is 0. So option 3 and 4 are the right option. That is option C. Okay, I hope this is clear to you, that any element that is in the element form or in the molecule form but not in compound form, the oxidation state will always be 0. Let's see question 92. Which equation shows the reduction of copper? So it's simple. Reduction of copper means you will lose oxygen or either you will gain the electrons. Let's see one by one. The first one is copper oxide, right? And then in the product, if you see, there is no oxygen. So it means what happened? The copper has been reduced. The loss of oxygen is the reduction. So this option is the right option. But we can look at the other option also. The copper sulfate you have first, and then it becomes copper oxide. So it gained the oxygen. So it is oxidation, right? Here, the copper gas changed to liquid, the liquid changed to solid. It is just the change in the state of the matter. No redox reaction is taking place. So option A is the only right option here. Let's see question 93. Which statement about reactants in redox reactions is correct? Okay, so now this question is related to oxidizing agent and reducing agent. Okay, so oxidizing agent, if you remember, oxidizing agent will always be the opposite. Oxidizing agent means anything that is reduced itself but is oxidizing another one. Okay, so an oxidizing agent will always reduce. Remember that one. It will never oxidize. So don't get confused. Most of the time the student get confused. They think oxidizing agent is the compound or an element that is actually oxidized. No, the agent job is always the different one. So if it is working as an oxidizing agent, it means itself it is reduced. Okay, so oxidizing agent always reduce. So an oxidizing agent donates electron. Wrong. Why oxidizing agent cannot donate electron? Because it is reduced. So what does it mean? It gains electrons. Reduction is actually the process of gaining the electrons. So that's why this option is wrong. When one element gains electron, the oxidation number of different elements increases. Okay. Okay, one element, if it is gaining an electron, what does it mean? It means it is reduced, right? Because it is gaining the electron. Then the oxidation number of a different element will increase. Yes, that option is right. Because if we have one element and this is the second element, the first element gain electron, right? So gaining electron means its oxidation number is reduced. What about the second element? Then the oxidation number of different element, that is 2, it will be increased because the oxidation number of this one has decreased. So the other one will increase. So that's why option B is the right option. But we can still look at option C and D. When the oxidation number of one element increase, for example, this oxidation number has been increased, a different element gains oxygen. Wrong. The oxidation number of one element, if it is increasing, it means it is the one actually that is gaining the oxygen. Okay, so that's why this option is also wrong. Now let's see D option. When the oxidation number of one element increase, a different element lose electron. Okay, so whenever the oxidation number of one element is increased, what will happen? Okay, if we have the oxidation number of, for example, we have two different elements, so the oxidation number of this element is increased, right? So what will happen? This different element is losing electron? No, it is gaining electron because this one oxidation number has increased. So what does oxidation number increase mean? It means the loss of electron. So the same element is actually losing the electron. So that's why option B is the right option. Okay. Question 94. Chlorine displaces the bromine from aqueous potassium bromine. The ionic equation for the reaction is shown here. Which statement about this reaction is correct? Now let's see the oxidation states. Chlorine, it's in the molecule form, so its oxidation state is 0. Here it is now -1. So it is decreased. Before it was 0, now it is -1. So chlorine is reduced. Bromine, it was -1. Now it changed to 0 because it is now in the molecule form. So this one is oxidized. The increase in oxidation number means oxidized. Decrease in oxidation number means it is reduced. So let's see now. Bromide ions act as an oxidizing agent. So what's happening to bromine? Bromine is oxidized. So agent job is different. It means bromine is actually the reducing agent now because it is reducing another substance, but itself it is oxidized. So reducing agent is the one that will itself oxidized. So bromine is not an oxidizing agent because bromine is actually oxidized itself. So when it's oxidized itself, it means it will reduce another substance. So this option is wrong. Bromide ions are oxidized. Yes, that is right. As electrons are lost. Yes. Oxidation means the loss of electrons. So option B is the right option. Chlorine acts as a reducing agent. Again, wrong. Chlorine is reduced. So it means it acts as a oxidizing agent. Oxidizing agent job is different, right? So if anything is reduced, it means it is actually the oxidizing agent. If anything is oxidized, then it means it's actually a reducing agent. So the agent is opposite of what actually happening to that compound. So chlorine is actually oxidizing agent. So this option is wrong. Chlorine is reduced, yes, as electrons are lost. Wrong. Electrons are gained. Whenever there is reduction, there is a gain of electrons. So only option B is the right option over here. Let's see question 95. In which equation is the underlying substance acting as a reducing agent? So reducing agent means any substance that is oxidized, right? So we have to check which one is oxidized. This one has one oxygen here, but now it gains two oxygen. So it means it is oxidized. So carbon monoxide is actually the reducing agent. But if you still want to look at other options, we can see one by one. Carbon dioxide, it has two oxygen here, but now it has one. What does it mean? The loss of oxygen. Loss of oxygen means reduction. So anything that is reduced, it is actually a reducing, it is an oxidizing agent, not a reducing agent. So that option is wrong. Copper oxide is reduced, not oxidized. Again, wrong. Calcium oxide, again, it is not oxidized. Okay, why not oxidized? Because it was still +2 here, and here it is still +2. So this reaction is even not a oxidation or redox reaction. So now option A is the only right option. in which the redox reaction is taking place, and carbon monoxide is the reducing agent because itself it is oxidized and it has reduced the iron, right? So option A is the right option over here. Let's see question 96. The equation for the redox reaction is shown over here. Potassium iodide is dash agent in this reaction because the iodide ions dash electrons. Which words complete the gaps? So now first of all we have to see what is happening to potassium iodide. What is the oxidation of potassium iodide here? If you see, K was +1 and I is now -1 over here, right? Let's see here what happens. The iodine becomes 0 here. So before it was -1, now it is 0. So loss in oxidation state, right? In oxidation number, you can say. So the oxidation number is decrease, right? Or increase. What do you think? It's increase, not decrease. It's increase because before it was -1, now it becomes 0. Right? Here the k is still the same. It is -2 here and the k is +1 here because +1 into 2 will be +2. So k, nothing changed to k. So now it's the oxidation state of only I is changing. So iodide was first -1. Now it becomes 0 because it is in now the element form, right? So it means the oxidation number has been increased. So what does it mean? It means it is oxidized, right? Oxidation, increase in oxidation number means the iodide ions are oxidized, right? So oxidized means it is the loss of electrons. Oxidation means the loss of electrons. So iodide ions will lose electrons. Clear? So if iodide ions is oxidized, what does it mean? Which agent is this one? Agent is always the opposite one. So it means potassium iodide is actually a reducing agent because itself it is oxidized. So reducing agent and the loss of electron is the right option. So that is option C. I hope this is clear to you that reducing agent is always the opposite of what is taking place. If anything is oxidized, it means it is actually a reducing agent, not an oxidizing agent. Okay, so if you remember this one, that oxidizing agent job is different and it itself it is acting differently, then you will choose the right option in the exam. So reducing agent means it will reduce an other substance, but itself it will be oxidized. So that's why option C is the right option. Okay, let's see this question. The equation for the reaction of sulfur dioxide with acidified potassium dichromate is shown over here. What is oxidized and what is the oxidizing agent? If you don't want to waste your time, you have to remember this thing that acidified potassium dichromate is already given in your book. It is written not as dichromate, but it is written potassium magnate. And they said that potassium magnate is an oxidizing agent. Potassium magnate and potassium dichromate, they both have almost same properties. So this is also an oxidizing agent. You have to remember this one, that this is actually an oxidizing agent, potassium dichromate. So if they are asking what is oxidized and what is oxidizing agent, so your answer should be potassium dichromate because that is oxidizing agent. So where you can see potassium dichromate ions, yes, it is here. So option A or D can be right. So now if potassium dichromate is an oxidizing agent, it means it will not oxidize. It will reduce, right? The job of oxidizing agent is different. So if it is reduced, who will be oxidized? It can be H2 or H, or it can be SO2. We don't have H option, we have just SO2. So that's why oxidize A option is the right option because sulfur dioxide will be oxidized. But this is the first trick you can find the answer, and that is option A. Okay, so option A is the right answer. But in exam, if you don't remember which one is oxidizing agent and which one is the reducing agent, so you can calculate the oxidation number. Once you calculate the oxidation number, you will find that who is oxidized and who is reduced. Let's see here now. Sulfur dioxide, if you see here, and now we have sulfur tetraoxide. Can you see here that oxygen number has been increased here? Before we have 2 oxygen, now we have 4 oxygen. It means this one is oxidized, right? You will think that, oh, this is -2 and before it was 0. No, let's check it again. SO2, if you see, O is -4, right? Because we have the oxidation state of oxygen is -2. -2 into 2, because we have 2, so total is -4. So sulfur is how much? Is +4. But if you look at over here, now SO4 -2, the answer should be -2, right? If O4 is -8, because we have 4 oxygen atoms and each one has the oxidation state how much? -2. So this is -8. So this one should be +6. So you can get -2, right? So can you see the oxidation state of sulfur has changed from +4 to +6? It has increased. So increase in oxidation state means it is oxidized. So what is oxidized? It is SO2. So obviously the oxidizing agent will be the opposite one. It can be H plus or Cr2O minus. So we can just simply look at the shortest one and the simplest one, that is H plus. If you see what happens to H, H is already a positive ion here. And here if you see it is -2 and this one is +1 into 2. So it is same. Nothing has changed. So it means it is not oxidized, it is not reduced. So it is not an oxidizing agent or reducing agent. So we are only left with the chromate ions. Okay, so dichromate ions are actually now the oxidizing agent. This is how you can find your answer. Okay, this is another trick to find through the oxidation numbers. So option A is the right option. Let's see question 98. Aqueous iron sulfate is added to acidified potassium magnate. The purple color of the potassium magnate disappears. Another one, aqueous potassium iodide is added to acidified potassium dichromate, a dark brown solution forms. Which row identifies the role of iron sulfate and potassium dichromate in these reactions? So now let's see one by one. I already told you that in your book it is already given that potassium magnate is an oxidizing agent. Okay, this one is an oxidizing agent. So if this is an oxidizing agent and you have added any compound and now the color has changed, it means the other compound is acting actually as it. This reaction is now a redox reaction. The other compound is actually acting as an opposite. If this one is oxidizing agent, it means this one is the reducing agent. Why reducing agent? Because the color has changed. If there was no change in the color, then it means this is not a reducing agent. Okay, so because the reducing agent will reduce potassium magnate, and that's why there is a change in color. So now they are asking what is aqueous iron sulfate, right? So it is a reducing agent. Why reducing agent? Because we already know that potassium magnate is a oxidizing agent. You have to remember this thing, because if you don't remember you will get confused who is oxidizing and who is reducing, right? Because it's already given in your book that potassium magnate is an oxidizing agent. And I already told you potassium magnate has similar properties like potassium dichromate. So if potassium magnate is oxidizing agent, potassium dichromate is also an oxidizing agent. And they are asking about potassium dichromate. Okay, so potassium dichromate is a oxidizing agent. So option D is the right option. Clear? And in your book, this is already given that potassium iodide is a reducing agent. Okay, even if you don't remember this one, you have to remember that potassium iodide is a reducing agent. And if the color of the potassium iodide change, you see it was colorless and now it becomes a dark brown solution. So it means the compound that you have added in potassium iodide, it is actually working as an opposite of this one. So potassium iodide, if it is a reducing agent, the other compound will be a oxidizing agent. So that's why potassium dichromate is a oxidizing agent. So option D is the right option over here. Let's see question 99. Hydrogen iodide is dissolved in water. Which row describe the final color seen when the solution is tested with damp lead red litmus paper, and with acidified aqueous potassium magnate. Again, this one we already know that it is an oxidizing agent. Okay, so if the potassium magnate, it is added into HI, so iodine, this one hydrogen iodide, when will react with potassium magnate, the color will change. This is a redox reaction. Oxidizing agent potassium magnate has a purple color. So if it gets reduced, because it's an oxidizing agent, so it will change to colorless. So colorless is the right answer, these two options. Then, which row describe the final color when the solution is tested with damp red litmus paper? It is acidic solution HI. So of course the litmus paper will remain the red. Okay, so that's why option D is the right option. The litmus paper will remain red because the iodide is actually acidic in nature. Okay, so that's why option D is the right option. So I hope these points are clear to you. You have get some tricks already for chapter 1 to 10. I will come with a new PPT that will be from chapter 11 to 21, giving all the tips and tricks related to the paper 2. Up till then, bye bye.